we mark everything as broken that's remaining. Some of those don't get backported properly, so then people are like, wait, why is this being marked broken? I fixed this. Other things, automating marking things broken is really hard when you're dealing with multiple Python versions, and it's really only broken for Python 2, and you accidentally mark it broken for both Python versions. So we might want to have some more time to discuss as a community, not just the release managers, but as a whole community, how we handle the zero Hydra failure process and how we ensure that the work done in the zero Hydra failure process gets into the release and doesn't just sit on master waiting for the following release.
And spend some more time on the release notes, because we ended up missing out a few things and adding some after the release, and also not optimal.
Yeah, and I think we didn't review the release notes until like a few hours or days basically before we actually did the release.
Yeah, we did it when we were doing the release,
Yeah.
basically. It makes sense to do that during the feature freeze.
And then define how to divide responsibilities.
As you can tell, we did this really well for the talk.
Yeah, exactly. Yeah, so seriously though, as co-release managers, and maybe even as we grow into a bigger Nix community, having more of a release management team, it's very important to define who's doing what. And there were definitely a number of key people that made this release happen, aside from us and just the general contributions, like the staging getting merged back in, and the staging next stuff. Fred H did a lot of that, so that was key to it. And maybe what we need to do is define some more roles in the release management team, that it's like, okay, I have a specific role. My role is to constantly review the release notes. I have a specific role. My role is to make sure big changes are getting merged back into master early and often, without breaking master all the time. So I think it's important for us to have more discussions about how we do this release process going forward as a community.
That said, I do have some statistics that weren't dependent on GitHub, and I managed to get thanks to my local copy of all the commits. So it'll be definitely commit focused and will not have much on issues or pull requests, unfortunately. But we can see we've had a pretty intense increase in commits, especially in 2018. Oh, that's funky. And 2019 is a bit less, obviously, because the year isn't over yet. But I think it's quite an exciting reflection of how we're growing. I think the room we were in London last year was a bit smaller as well and had a few less people. Yes, so that's nice. Yeah, that reflects the same trend. Again, we've got a bit less for 2019 because the year's not over yet. Do you want to say?
Yeah. So commits per year. What? Committers per year. Yeah, so this slide basically shows that we're on a growing trend, and it's nearly exponential up until most recently, where it's kind of tapered off a little bit. But yeah, I mean, we definitely have more and more people committing every single release, and it's really exciting how fast this community is growing.
Also, if you look at the access label, you'll see that that's 1,200 for 2018. So that's quite a few people. We have a lot of people working on Nix packages.
Yeah, and there are still 2 months left, so if you want to be counted in that number, find a PR to work on, do something to help out, and you'll increase it even higher.
And if you've already done so, get a friend to do it.
Absolutely.
Ask a friend if you can commit code to Nix packages in their name. Yeah, same trend again. We've got some decreasing percentages, which I think is primarily an artifact of how it's a relative measure of growth, and I remember a comic or something where someone said, "I've just founded a religion. Will you join my religion?" And then pointed out that he had 100% growth in his religion. So with our Nix religion, we have a slightly smaller growth, which is in part due to the absolute growth. But yeah, it's nice to see more people.
And commits committer per year. So one of the nice trends we see here is if you look in 2009, the number of commits per committer is rather high, like over 250, which is just unsustainable over the course of a long period of time. And we're actually in a downward trend that's tapering off pretty well. With the number of commits per committer now, and a huge portion of that is basically because we just have a whole lot more committers. I don't think it's because people are being more lazy, it's just there's more people to go around to do the work, so it kind of trends off a little bit.
Yeah, so it's nice to have the responsibility being more distributed. At least I hope that's what we can interpret from that trend.
And number of commits per day. I'm guessing this is when the feature branch off was probably. But you can see it's kind of growing up, and then it just like plummets completely.
The drop off is probably because that was the day on which we tagged the release.
That's why I was wondering. Okay, so that's the day we tagged the release. That's why the commits dropped down.
And it only goes up to the release tag.
Okay, got it.
And that's a slightly shorter range of time, last 36 months of commits per day. Yes, it's a wavy line. And that's all we have in terms of statistics.
Yep. So I'd like to open the floor kind of to anyone that has any questions about the release process, has any things they want to add. Yes.
Hi, thank you for the release. I have a question about the commits per committer. Do you have any idea of like how many of those are like basically like just one-liners, as in like updating a version?
We don't have a statistic on that. We could probably get something like that, but I think a lot of them tend to not be just one-liners on the big ones. I mean, the ones that are making tons and tons of commits, like I think World of Peace was ranked up there as one of the higher ones. He was working on some pretty intense stuff across like all sorts of different parts, including the standard environment and whatnot. So I don't think it's just people bumping things, especially now that we have the Ryan TM bot basically bumping almost everything, and all those are credited to one committer now instead of someone that's not a bot getting credit for it.
Yeah, as for actual statistics on that, the numbers are there, but I don't trust myself to get live coding some graphs in Python right. So, no.
I have a question about the zero Hydra failure. So when I saw the ticket and progress being made on it, one of the questions I had is there a way to search on Hydra to see all of the packages that are failing for which I am listed as a maintainer?
That is a good question, and I don't think there is, which is kind of why we have that Python script in the maintainers page that basically pings everyone. And it took us a little while. We didn't get that working quite the day we announced the zero Hydra failures. It wasn't until about a week or two after that when I got that script functioning properly again because of some breaking changes. that happened with how the maintainers are listed and whatnot. And that is one thing I would definitely suggest as a takeaway as well. Getting scripts like that are important to the release managers with some CI tests on them, because that would be an easy thing to basically check and make sure that the maintainer's structure isn't going to break that script going forward, so we know when things are breaking much earlier in it. Graham.
What was the most rewarding part of being a release manager?
Ooh, the most rewarding part of being a release manager. I think it was probably seeing like how many people came together to fix things and whatnot, especially at the last minute. It would be nice if we didn't have that last minute dash and whatnot, but definitely there's a huge push by people, and people work together to make the release come together. It's not just us, it's a whole community that's doing these things.
For me, I think it might be the satisfaction of when it's done and I'm I'm free of the pressure. Yeah. Although I'm very happy to have made the contribution, as Sam said. So yeah, not just that.
Anyone else? Graham. Yeah, as I mentioned a little earlier, I think, what? Oh, are there
Are there ways we could change the release process or the contribution process to make releases easier to do?
Yes. So as I mentioned earlier, having more of a team effort and having like regular team meetings for the people that are involved in doing the release, rather than just the two release managers doing things and other people doing their own things and whatnot. Having a more organized effort and whatnot, and knowing who's responsible for what pieces of the release. I think that would definitely help the release go a whole lot more smoother. And maybe we might actually hit the release in the same month if we did something like that. And then someone back there had a question.
Just to add to that answer quickly, I think it would be nice to have notifications for maintainers from Hydra again. Yeah, just not spam when the standard env breaks.
I just wanted to say, don't be too humble. My friend reports this is the first release that didn't break his configuration, so congrats.
Although releases are for breaking configurations. So
That just means we didn't release enough features, right?
Right, I think that's it.
Yep. Unless anyone else has any other questions. There's one more.
What are the most notable features?
The most notable feature by far is GCC 8. Also, one feature I'm really liking is the update of systemd. So when your systemd services stop, it tells you a summary of how much network usage and CPU usage and memory the service had. Adding that new feature to systemd has made my life debugging crashing services so much more fun.
Yeah. Yes?
I wanted to make a suggestion about the difficulty having weekly meetings, especially across time zones. I'm a big fan of just writing, not necessarily a blog article, but public would be good since it's a distributed, all of us are very distributed, and it's nice to know what's happening. And just like writing to each other weekly would probably go a long way to hitting the necessary buckets that having a meeting would hit, as well as making it public.
That sounds good.
Yeah, that does sound good. I'm horrible at writing things down, but that does sound very good.
And as a closing note, I'd like to also thank my employer Mayflower for giving me work time to spend on the release.
Yeah, and IOHK gave me a little bit of time. I didn't have that much because of other things going on and whatnot, so I ended up doing a lot of the release work outside of my normal workday. But a huge thanks to IOHK for letting me spend some time working on Nix PKG's issues and whatnot.
And the whole community. There were so many people who contributed to the release. Remember? That's a lot of people.
And one more thing to close out. If you are interested in being a future release manager, please talk to me here or send me an email or something, and we'll go from there on that. Thank you.
What's called the discovery track, where you can come do some sort of like interactive learning about Nix and NixOS and sort of learn some things. If you feel a little bit lost, then we can help answer some questions and teach you a little bit. Hope to see you there.
Next up is our own Elko Dostra, the author of Nix, with his Nix Flakes talk. Give him a hand, everyone.
All right, can you hear me? Good sound? Testing. Testing. All right, sounds good. Like this? Oh, okay. All right, so thank you all for coming. Welcome to NixCon. And by the way, let me first give a big shout out to our release managers, Samuel and Linus, and everybody else who contributed to a really great release, extremely smooth. So yeah, it's really incredible to see that that happening. Yeah, this talk is about Nix Flakes, which is a new, well, experimental feature in Nix. It actually came out of a talk given by Shay Levy at last year's NixCon about require.nix. So that was about, yeah, essentially being able to compose Nix-based projects in multiple repositories, making them more discoverable and giving them a standard structure. And yeah, that's something that I really wanted for a long time, and yeah, also address a bunch of other big problems that we've had in Nix for years. Yeah, for the last year I've been hacking on that, so that has actually been funded by Shay's company, Target. So they've been paying my employer, Tweak, to work on that. So let me first talk a bit about all the problems that we're trying to solve here, because there are quite a few. So very briefly, flakes are a way to package your Nix files. So that might sound a bit strange because Nix is already a package manager, so, but it's a bit embarrassing. So it's a very nice package manager, but it's not very good at actually packaging its own stuff. So Nix expressions, well, I mean, we've had these things called channels, but other than that, and channels don't work very well. But other than that, yeah, it's getting your Nix expressions to users or to other developers is kind of a mess. So let's go through all these problems. So one problem that we've had is if you have a large system spread out across multiple repositories, then it's not convenient to build that with Nix. So for example, at a previous job, we had this big system that was actually, so it was a multi-repo project, so it had components spread across, I think, dozens of repositories. So just building that system meant you had to more or less manually check out all those repositories, make sure that they're in the right place, maybe set up the NixPath environment variable, because these repositories were all depending on each other through NixPath, or just importing each other via .. So every repository had to be in the right location relative to each other. And that's not a nice developer experience. So basically, if you need a readme.md explaining how to build a project, you've already failed. So for example, if you check out a Rust project, you can just do cargo build and it will always work. With a Nix project, everything had a different convention, and everybody developed their own ways of doing these things. So yeah, that's not good. So the vision here is that any Nix-based project should be able to do a git clone and run Nix build, and it should work. So related to that is that Nix projects don't really have a standard structure. So there are a few conventions. You might have a shell.nix file, or a release.nix file for your Hydra jobs, or maybe a default.nix, but actually default.nix doesn't actually have a standard structure. It's not defined whether that's one package or a set of packages or arbitrary other stuff. So for example, all packages.nix in Nix packages is some weird mix of packages and library functions and builders. And then there are things like NixOS modules, which where there is really no convention. So if you have a project that provides a NixOS module, there is no convention on what that file should be named like, and how you should pull it into your own system configuration. So we want to have a standard structure, just like, say, you have a cargo.toml in a Rust project. There should be a standard interface to a Nix-based project. So another goal is improving reproducibility. So a bit of another embarrassing thing about Nix is that it pioneered reproducible builds, but the evaluation of Nix expressions themselves is not all that reproducible, despite the fact that it's a purely functional language. So the problem is not so much the purity of the language, but the fact that evaluation is not hermetic. So a Nix expression can pull in arbitrary files from your file system. So for example, it can, something that happens in Nix packages, it will read in .config/Nix packages/config.nix or something like that. So that means that if two people check out the same repository and do a Nix build on that, they might get a different result, which is obviously a bad thing. And there are other sources of contamination, like using environment variables, or calling fetch git to fetch a Git repository without specifying a revision, so then it will just fetch the latest head revision. So yeah, that's not reproducible. And that also has implications like you cannot cache evaluation results persistently. So the goal of Flakes is, so if two people build the same flake, they will always get the same result. So another goal is replacing Nix channel. So Nix channel is the main way that we distribute Nix packages and NixOS to users, but it's pretty limited. So it's hard to actually create a channel. I mean, it's not really that hard. I mean, it's just a tarball containing a dump of your repository, but just creating that thing is not something you want to do. You just want to point somebody at a Git repository, and it should just work. So with Nix channel, you also cannot easily pin a channel to a specific version. You can only say Nix channel update, and they will get the latest channel, but you cannot roll back to a previous version. Channels don't really auto-update, so that's kind of the opposite of pinning. But so if you don't run Nix channel --update, then your system doesn't, or nothing updates at all, and that might not be what you want because you don't get any security fixes or other fixes. And they're completely self-contained, so channels cannot express dependencies on other channels, which basically means that they're only useful for distributing Nix packages, because Nix package is the only thing that doesn't depend on other repositories. Most other Nix projects will depend on Nix packages, so that means you can't really use them as a channel. I mean, you can hack things, or you can use the Nix search path, but then you're back to that problem of reproducibility. So yeah, we need to provide something nicer than Nix channels. And then finally, we actually, I mean, that's an extension of replacing Nix channel, but we actually need to finish the Nix CLI. So have one command replacement for all the existing Nix tools was actually something I first proposed at the first NixCon in Berlin. And so embarrassingly, we're still not there yet. So so it doesn't have replacements for NixEnv, Nix shell, and Nix channel. And actually, one major blocker there was that, well, so these commands, so they try to provide a unified interface for all these commands. So with the old interface, for example, NixEnv and NixBuild have a completely different user interface. They have a completely different way of referring to packages. So NixEnv uses package names, and NixBuild uses attribute names. Yeah. and Nix channel, of course, is completely different. So the goal there was to unify these things, but it was always a blocker that, I mean, I had in my head that Nix channel is a mess, and Nix path is a mess, so we need a replacement for that. So we need to have a good answer to the question of what does Nix build Nix packages.hello mean. So currently it means, well, look up Nix packages in the search path, so in the Nix path environment variable, and probably that's populated using the Nix channel command, so that's where you get your Nix packages from. But so that has all these previous problems, so we need a better answer to that. So yeah, so Flake provides a answer to that. All right. So now let's get to the actual solution. So first, before actually diving into what a flake looks like, let's look at it from a developer point of view. But very briefly, a flake is just, well, simply put, it's just a Git repository that has a flake.nix file in it. And the flake.nix file describes what that thing describes, like Nix packages or modules or overlays or containers, basically any kind of Nix values, but it provides some standardized structure to them. So suppose that we want to run Rust from Nix packages. So yeah, you would say Nix run Nix packages #rustc and then -c rustc -version, so you run it. So this is almost exactly the same as what you would do in old school Nix. So the only difference is that the dot has changed into a hash. So you say Nix packages #rustc instead of .rustc. But it does something completely different. So in the old Nix, this would go through the Nix path and through your Nix channels and look for Nix packages. So here, so Nix packages is a identifier that is so-called flake reference. And flake references describe, well, the location of the flake, and that can be a URL. So, for example, a GitHub, a repository on GitHub, but that's not very user-friendly if you have to type that all the time. So you can type it, but usually you use this so-called registry. So there is a global registry that has some mappings from well-known repositories or well-known flakes to their actual locations. So what this command will do is it will fetch the latest registry. I mean, it caches it, so most of the time it won't actually be fetching anything. So it will look for the location of Nix packages, and then it will fetch Nix packages. So unlike Nix channel, you don't have to add anything, you don't have to configure anything. This just works. So, all right, so it works, that's great. So these flake references, you can also vary on them. So Nix packages is looked up on the registry, but and in the default registry, Nix packages is mapped to the master branch or the unstable branch of Nix packages. I might change that in the future because maybe it's not a good idea, but in any case. But suppose we want to use the release 1909 branch, then you just say Nix run Nix packages /release 1909, and that will fetch the head revision of 1909, which has an older Rust version. So these commands, by the way, are not very reproducible because they're referring to head revisions of repositories. But yeah, so, okay, so there can be any number of flakes. So for example, in the flake world, the patch shelf project has a flake.nix file. So if we want to run the latest and greatest patch shelf, we just say nix run patch shelf, and this will fetch the patch shelf repository, build it, and run it. Now, so if we want something more reproducible, we can also use a so-called immutable flake reference. So that's one that doesn't refer to a branch or tag, but to an actual revision. So, and ideally doesn't indirect through the registry because the registry might change. So I can say something like nix run GitHub, and then an actual project and a revision. And so this will always provide the same result, of course, provided that this repository doesn't disappear. So that's something I don't have a solution for at the moment yet, but all right. Yeah, a little bit more user perspective. So, so the difference with Nix channel here is that you get the latest version of Nix packages by default. So it might not be what you want. So you can also pin a flake. So what that does actually is, so you have a global registry, but there's also a per user registry, and these pin and add commands just register a override in your local registry. So Nix Flake pin will add an override that makes Nix packages point to the current revision, and after that it doesn't change, so you always get the same thing. Or you can say, you can explicitly make Nix packages point to anything you want, so you can make it point to your own fork or to some branch that you want, whatever. All right. Very briefly, I can mention that since a few days ago, there's also a Nix env replacement, so you can now say Nix profile install Nix packages #hello, and this is a little bit nicer than Nix env because it remembers where these things actually came from. So it will store in the profile that this Nix packages #hello resolved to a particular revision. So yeah, you can always reproduce that thing. You always know exactly what's in your profile, but you can also upgrade that, and it also remembers your original URL that you used to install it. So it will. So if you run upgrade, it will fetch the latest Nix package and rebuild from there. So you get a mix between sort of imperative and declarative style. All right, so that was the user perspective. Now a bit of the developer perspective. So suppose you want to hack on a flake. So there is actually a little convenience command, Nix Flake clone, which, so this will look up a flake in the registry. Here in NixOS homepage, that's the nixos.org homepage, it's actually built using a flake. So this just runs a git clone. So we can go into it, we can edit it a bit, and now we can run Nix build. And so this just works, which is not entirely trivial because the NixOS homepage actually depends on multiple versions of Nix packages, and it pulls in Hydra and NixOps and the master of Nix because it needs to prettify their manual, so all sorts of silly things going on there. But you don't need to know about it. You just run Nix build and it works. All right. So Nix build by default, it builds this so-called default package that a flake provides, but a flake can provide more than one package, obviously, as in the case of Nix packages. So, for example, in NixOS homepage, there is this packages explorer derivation, and if you want to test that thing independently, you would say something like nix build # packages explorer. So dot refers to the current directory, and # packages explorer is the attribute in the flake that you're interested in. There's also a Nix shell replacement. It's called Nix dev shell, and that uses by default it uses the default package provided by your flake, and but you can also have an explicit dev shell thing provided by your flake. So if you want to set up a very fancy environment that differs from the actual package, then you can declaratively specify that. Another thing worth mentioning is there is a Nix Flake check command, so that will check whether everything in your flake evaluates correctly, and it will build a special check attribute in your flake. So you can put some smoke tests in there. So this is a nice way to verify that your flake is still correct. And flakes can provide many things. So for example, they can provide NixOS system configurations. So NixOS container has flake support, so you can say, run the NixOS homepage flake in a container, and that will build the NixOS configurations dot container attribute from the flake. So that's all completely reproducible. So if two people run this command on the same revision of this repository, they will always get exactly the same container. So then you can start it, and you can run it, and yeah, that's nice for the home page because all these things like packages.json work because they need some special web server configuration. So yeah, that's nice. All right, so now what actually is a flake? So how am I doing in time, by the way? All right, I'll assume that's okay. So what is a flake? So a flake is actually just a little bit of metadata around the Nix expressions that you already have. So your default.nix or your release.nix. So the metadata is things like a description and an addition. And the dependencies of the flake, so the other flakes that it depends on, like Nix packages. And then the main thing is the outputs of the flake, so those are the values that it actually provides. So here's an example. So this is from a flake called dwarf.fs, which is a little fuse file system for fetching dwarf debug info on demand. So it has a description. It has an edition field that's mandatory, so the edition currently needs to be 2019-09, and that's actually a nice feature because this will allow us to evolve not just flakes themselves, but the Nix syntax and semantics in the future. So if we want to do things like, remove the URL syntax from the Nix language, then the edition field allows that. So at some point we would bump this to 2020 something, and then old flakes would still be parsed using the old syntax, and new flakes using the new one. All right, so the main thing here is the outputs. So there are some packages here. Well, there's actually only one package. There's a default package which just aliases that package, and there is a NixOS module .dwarf.fs. And this flake has some dependencies. Well, actually it has only one dependencies, and these are passed in as function arguments. And those are other flakes. So there's one called self, which is just this flake itself, so you can refer to the flake's own outputs. So for example, here we're referring to self.packages, which is actually this thing up here. And that's sometimes useful for referring to some metadata of the flake. But the main thing here is Nix packages. So we're not saying anything here about where we get Nix packages from. You actually can specify that, so it's not shown here, but you can specify an inputs attribute here, which actually specifies where the inputs come from. But if you don't specify that, if you just have a function argument here, then it will be looked up in the registry. So Nix packages will be looked up in the registry, and that's what is used to build this thing. Now that sounds very non-reproducible, but so the solution is that there is a log file, just as you know from npm or cargo. So when you build a flake, so you have a flake.nix, it will look up all these dependencies, and that's extremely impure, but then it will generate a flake.log file, which maps those impure dependencies to concrete revisions. So for example, Nix packages will be mapped to NixOS/Nix packages / whatever revisions happens to be current at that time. And once the log file exists, it will be used by any subsequent build. So if you run Nix build again, it will use that the dependencies locked in the log file. And so you would generally commit that log file as part of your repository. And then things are wonderfully reproducible. So for example, in Hydra is always, configuring Hydra job sets has always been unpleasant because you have to specify these job set inputs. That can get very messy if you have dozens of repositories that you depend on. But now you no longer need to do any of that. The only thing that you need to configure in Hydra is the URL of your flake, and that flake will have a log file that completely locks all the dependencies. So that's all Hydra needs to know. Another nice thing about reproducibility is that now if you want to, something fails in Hydra and you want to try that out yourself. So Hydra has this little known feature where you can click somewhere in a menu on reproduce this build, and what it used to do is generate a shell script that tries to reproduce all the dependencies of your project. So that will generate all these calls to Git and Mercurial to fetch all your dependencies. Most of the time that doesn't really work. So now that's completely unnecessary, because you can just say, you can just cut and paste this one-liner. So for example, Nix build, and then the so-called immutable flake reference. So for example, GitHub NixOS/Nix/revision, and then the attribute that this Hydra job corresponds to. So Hydra jobs.build.x8664 Linux. And that's guaranteed to give you exactly the same thing as what Hydra was building. I skipped this one. So what are the outputs of a flake? So a flake can provide anything, but there are a few well-known outputs. So if they exist, and Nix Flake check actually requires them to have a certain format. So for example, the packages attribute must be a set of derivations. So if you put other stuff in it, it will complain. So other well-known ones are Nix packages overlays, NixOS modules, system configurations, CI jobs like Hydra jobs, dev shell environments, and so on. But other than that, you're completely free to have arbitrary outputs. So flakes are just a little bit of a wrapper around your Nix expressions. Let me also still mention that there's some basic flake support in NixOS. That's really nice, because it used to be very annoying in NixOS to, if you want to pull in something that's not in the Nix packages repository, there's not a super easy way to do it, but now you can. So for example, here's a NixOS configuration for a Hydra server. So I just say, well, I need Hydra as an input, and then in my modules I say hydra.nixosmodules.hydra, and it just works. And this, for the first time, also allows us to get rid of things like Hydra in Nix packages. So it was always very embarrassing in Nix that if you have a Nix-based project, so something that has a Nix expression or a NixOS module, it was very hard to actually ship that in Nix packages, because we had to actually reproduce all that stuff in Nix packages. So Nix packages has an outdated clone of the NixOS module for Hydra. So that's not a very nice approach. So now we can just get rid of these things, and you can just use the Hydra flake directly. Or for that matter, the Nix Flake. So if you want the bleeding edge of Nix, then these two lines are all you need to do. Just pull in the Nix overlay from the Nix Flake, and you're ready. All right, so there is an RFC. None of what I described here is actually in Nix Master, and none of it is set in stone. So all of this is subject to change. Or maybe we'll throw it away. We decide it's a bad idea, but hopefully not. So you can play with it. So I'm very interested in feedback, and I think that's it. Right. Questions?
Hi. So I'm curious, clamping down on impurities seems to remove a really important lever for injecting authorization to get private stuff? Like, what's the story for that?
Yeah, so basically that should just work. So for example, for GitHub, currently Flakes have, Flakes are fundamentally agnostic as to how Flakes are fetched, but currently they're just Git and GitHub as a sort of transport mechanism. Now, so Git just uses whatever authentication mechanisms you have. So if it's not executed by the daemon, all that fetching. So it's just run as your normal user account. So it can use your SSH keys or whatever. For GitHub, I think we have some configuration setting where you can configure access tokens. So you can use that for fetching private repos. So yeah, so this is a use case that we're aware of. Because actually, so Target, the customer that funded this, of course they have all these internal repos. So yeah, so that's something that needs to work.
Okay, cool.
Hi, how can we try this out?
So there is a Nix Flakes attribute in Nix packages. So you can set in NixOS you can set config.nix.package to Nix Flakes, and then you get a Nix Flakes enabled system. Or you can do Nix run Nix Flakes from Nix packages. The caveat that the one on release 1909 is currently sort of broken, because a few days ago GitHub changed their the e-tags that they're serving for their archives. So I was abusing the fact that their e-tags were actually Git revisions, and I had no reason to actually assume that that would always be the case, and that stopped being the case a few days ago. So so I fixed that, but that's not on release 1909 yet. But so I'll have to backport that. But yeah.
We have some necessary impurities, like the current system. How are you handling this? Like AR64 or x86-64, it's an impurity, but it's like a requirement to work. How are you handling it with as a reproducible manner?
I didn't actually see the questionnaire, but I think the question was about multi-platform support, right? So
yeah.
Yeah. So I hoped you wouldn't ask that. Until last week or so, it didn't actually have multi-platform support. So the problem here is that you need to somehow pass in the system argument, you need to. Okay, so Flakes want to be completely reproducible, and if you pass in something like a system argument as a function argument to the Flake, then it would it would be sort of reproducible, but it would no longer be enumerable. So you wouldn't be able to ask a Flake what its contents are anymore, and also passing in function arguments would open the door to all sorts of configuration. And then before you know it, you need a readme.md again to figure out how to build it. So I might still do that in the future. So maybe this is the most practical way to just have a system function argument there. But for now, what I've done is, so the Nix command will just evaluate packages dot current system. So it's up to the Flake to decide which platforms it supports. So this particular Flake, so it doesn't actually look like this in the real world. It's written a bit more general, so it emits attributes for every platform that it supports. So that is a little bit more verbose. It adds a line of code per output, but it's not too bad. So it's the responsibility of the Flake to actually say what it supports. Now you could say that's a little bit nasty because it means you cannot build the Flake on platforms that the Flake offer didn't choose to support. But sort of in the Flake philosophy, the solution to that would always be to create another flake that pulls in the original flake and, for instance, uses its overlay to instantiate that package for whatever architecture or maybe even cross-compiled architecture you're interested in. So the packages output here is only something for the Nix CLI, and things like overlays or modules would work on any platform, or, well, I mean, they would evaluate on a platform. Whether they work is another question, but yeah. So, but yeah, so this is still a bit where we have to experiment about what the best approach is.
So we only have time for one more question, and I think it was...
Hi, thanks for the talk. It was a feature we were all waiting for. The question I have, when you were talking about Hydra and when you have the reproducible builds where you can click and you get the command. So the question is, what if you have, so this Nix homepage depends on multiple other flakes, and when you specify the build, this doesn't pin the other flakes, which are not kind of under your control. Isn't that not reproducible then?
So the log file...
To kind of log file recursively for all the flakes that you also depend on.
Well, so it's actually not done recursively. The top level flake.log file logs all the dependencies, also the transitive dependencies. So it would look at the flake.log file of the NixOS homepage repository, and that logs everything. So not just the top level thing, but also the transitive ones.
So you have to have flake log
yes,
file
exactly.
always.
Exactly. So what that doesn't do is, if you want Hydra to be testing, well, to do an actual integration test, so to build NixOS homepage against the latest version of those dependencies, you currently cannot do that because it would require Hydra to update the flake.log file, which in itself wouldn't be the problem, but then it would have to register that flake.log file somewhere to make it reproducible by user. So it would have to store it in the database, or so I mean that's not an unsolvable problem, obviously, but I haven't done that yet. All right, thank you.
Let's take a 10-minute break. Tenzing is going to talk to us about some containers on NixOS and some Docker Compose goodness.
All right. Yeah, so this talk is about Arion. I'm Robert. I'm co-founder of Hercules Labs. We actually did launch of Hercules CI this week, so that also means I've been a bit busy. So I hope this presentation is sort of going to plan. All right, let's get started. So Arion, come on. Probably window focus. All right. It's a configuration language, so to speak, for Docker Compose. It's based on the NixOS module system. And it's also the tool that you can use to actually create the containers and restart them, that kind of thing. It's named after a horse. It's a divine horse from Greek mythology. And we chose the name because, well, obviously we have Greek mythology in the name of the company. And it's a very fast horse. I'll get to that. And it's also a bit of a mix, and it can talk. So I thought it was appropriate. So yeah, the way this came to be is we were looking for a process manager kind of thing for our local development environments. We've been using supervisor D for cachix, but it had some problems with properly terminating processes. So we were looking for something else. I've worked with some tmux automation, but that was a bit too custom, and well, it's not really designed for this purpose. We looked into systemd, but that doesn't really support like project-based stuff very well. NixOS containers, those are obviously very nice, but for project development, if you want to do stuff like live reloading, it was a bit, well, not flexible enough. You need to bind mount stuff into the container, and maybe this has improved, I don't know. At least at the time, NixOS containers weren't a good option for this problem. So we considered Docker Compose. Well, I guess I don't have to talk that much about Nix on this conference in terms of basic explaining. It's really nice to have a programming language for your configuration. And with Nix, we can use the module system, which is really nice. So yeah, the way we started to develop this sort of solution is to just try things out. So this is what I ran, just Docker run. It has the Nix store bind mounted right into the container, so you don't have to rebuild everything or build images. And yeah, you don't really need anything else, basically, or at least as a starting point, you don't need much else in your container. So we just run Scratch, but yeah, that's not an option for some reason. So you put a file in there with like root and nobody, and it actually works. But yeah, so we had to create the image, and it was pretty clear that we need something like Docker Compose to actually do this. Was already sort of the plan, but yeah. So Docker Compose is a system that lets you define multi-container applications and perform operations on them, like building all the containers, building all the images, I should say, and starting them, destroying the deployment, all the kind of things you expect from a deployment tool. And a basic configuration file looks like this. It's YAML. People might have opinions about it. The nice thing is it's a superset of JSON, so we can easily write these files from Nix. Yeah, so what you see here is a set of services. It's like a dictionary kind of thing. So this is service name. This basically says, look in the current directory for a Docker file, and it'll use the service name as the image name. This will expose port 5000 to the host, and there's an extra service for the backend. So Arion, it really started out as just a small bash script that did a thing for us. But with the module system, it's really easy to refactor, and it was quite fun to make it more of a self-contained thing. So as it grew, we open sourced it around December, I guess. Yeah, so I think we announced it, and since then it grew from, I think it was 200 lines of bash code. It grew into 317. It's not that bad, actually. Bash is a really nice language for this kind of thing. But up to a point, we were thinking of some features that would be hard to implement in Bash. So we switched to Haskell. That did double the lines of code, but we think they're more maintainable lines. So in the end, that should be a good thing. But really, most of the project is Nix modules, and some support code like tests, of course, that also add to the sort of the line count. All right, so demo time. It's always interesting. See if it works. All right, so this is inside the repo checkout. There's an examples directory. You should have a look at it. But I'll also show the basics. So these are, well, obviously result is, it shouldn't be there, but there's Arion packages and Arion compose files. For the bootstrapping, Arion needs to find some version of Nix packages. Often in projects it's the case that you have a specific version of Nix packages. I mean, this is before Flakes, right? So yeah, you have some version of Nix packages, probably some overlays that are specific to the project, and you want to use those in your deployment. So in this case, it's a very simple invocation of just Nix packages with the system set to Linux, because that's what you're deploying most of the time. And that's really just for bootstrapping and for providing the packages argument to the modules. And then we have the compose file. It looks quite a bit like NixOS. The NixOS module system is basically independent of NixOS, and you can do a lot of cool stuff with it. It doesn't have to be NixOS itself. So in this case, we did have like insert the packages just like you have on NixOS. But these are Docker Compose services. And so one of the nice things is ability to share the host store. So you don't have to build images when you're coding. And yeah, I think this should be somewhat self-explanatory. It's a web server. And now you can start it with the up command. And yeah, so it's actually started. Doesn't produce much output. I've already built the thing, so what happened behind the scenes is the NixOS, I should say probably the Nix module system, was invoked to evaluate that configuration. It was built with Nix build to produce the Docker Compose file, which has all the references to stuff like this path here for the Nix documentation, and that just makes it work. If I go to localhost 8000, come on. My browser is a bit shy, it turns out. Oh, that should do. There it is. All right, so this is a fairly, well, as it says, it's the minimal example. This is just using Nix and Docker Compose. But we also put some effort to support NixOS on this. So I'll stop this deployment. It's actually called a project in Docker Compose terminology. In Arion, it's a composition. Project is a bit overloaded. All right, so it's still, services is still an Arion level service. So it corresponds to a Docker Compose service. But we have some extra fields here provided by one of the Arion modules, which takes care of the NixOS integration. And so everything below the NixOS.configuration is passed into the NixOS module system and evaluated there. And this automatically sets the service command field to the systemd or init invocation for NixOS. And it configures the Docker with the right settings. Took a bit of research to get it to work. But there you go, I think. Name service cache daemon didn't start well. Don't think we need that. Sorry? Ah. works again. It's basically the same thing, but now it's running with much more stuff around it to like clean up, /temp, that kind of thing that most containers don't need, but if you need it, it's really nice to have it, I guess. Yeah, so that's the basic thing. Yeah, so there's lots of nice things you can do. For development, for example, we're using bind mounts to do live reloading or hot reloading of our services, which makes for a nice development experience for a quick iteration loop. Let's see, back to the slides. Right. So I thought it would be nice to talk about the module system, because it's I think it's really cool. It's a really nice way to work with a certain type of complexity, so to speak. It's the kind of thing you see in NixOS, but it also really applies nicely to, well, to Arion, of course. And I think there's lots of applications that benefit from the module system. For example, I think there's a talk from IOHK about the Haskell.nix alternative Haskell infrastructure. I think that's using the module system. And I really like it. Okay, so one of the basic things you need to know about the module system is that there's basically no difference between your configuration and other modules that are usually provided by, say, NixOS or Arion in this case. So I think this is really an important feature, because it lets you factor things out into separate modules and actually take advantage of having a programming language as your configuration language. Yeah, so this is what a basic invocation of the module system looks like. It's a bit of a contrived example, but I'll walk you through it. Suppose you have a call of Nix packages. All you need to do is call lib.eval modules. And by the way, if you don't have Nix packages itself, you can directly import the lib directory, so you don't have to choose even a system architecture in advance. But if you do have Nix packages, you can take it from here. And you just invoke it, you tell it where the modules are, and you get back an attribute set with config in it. It's the same config that you get passed into the modules. So this lets you use the config in whatever context you have. Yeah, you'll always have the lib argument passed to it. That's built into the module system. Also options that lets you do introspection into which options are available. Packages, it's actually a bit of a lie. That one is not built into the module system itself. So if you want to have it, you actually need to declare it as an option. Should probably have put that on the slide. Well, ask me after the talk. Yeah, and so this should be, I guess, more familiar. The config prefix here is optional. So if you're not declaring options, config, or imports, but just foo is whatever, that actually means config.foo. And these are so these values are then combined with the other modules in the configuration, And so, for example, here bar should probably define config.bar to some value, and it's made available here. But this module is also free to declare its own config.bar, and if there's two definitions, in the module system you can have a merge function that combines the two values. So this config will always have the combined values from all the modules together. There's some sort of fancy things you can do. Arion relies on submodules. Basically, whenever you see angle brackets name in the NixOS documentation, that means that's a submodule. In NixOS, usually they're just data, so to speak, but that's not necessary. You can actually do anything you like in these modules. They're proper modules. So in Arion, I didn't really expect this because I was more familiar with the way it was used in NixOS, but I didn't really look into it that much yet. So it was only recently that I refactored it into proper submodules, so you don't have to manually call the module system for each of the services. It's just a type that says services are submodules, these modules. So that's really nice, and you can actually do stuff like imports in this sort of subtree of the composition. And that means that this file will be evaluated, and it can only set things for services.web itself. It's in its own namespace. This is something we figured out. The module system relies heavily on lazy evaluation to make things work, because obviously when you're declaring the config, but you're also getting it back as an argument merged with other things, that's recursion going on there. And because of laziness, it can actually work. But I used to be quite wary of it. I've run into situations where there was an infinite loop due to the way things are structured in the module system. So it's nice to discover that some of the more fancy things actually do work. Because normally when you when you declare the configuration, the structure of that attribute set should not depend on the configuration directly. It's kind of mind-bending, but that's what it is. So turns out you don't actually need to do that all the time. In some cases, you can, for example, look at options instead, which is available sort of earlier in the recursion, and you can use it to check whether some options are available. We've used it, for example, to provide a better NixOps integration in the Hercules CI agent. So if you just declare NixOps specific stuff in NixOS, you'll be declaring values that are undefined. There's no deployment namespace in NixOS, so that's an error. So with this sort of pattern, you can make this optional, and I think this will be very useful if we sort of decentralize NixOS, which I think is a really good idea, and with Flakes, it actually becomes feasible to do so. You can use this to detect whether something is available or not, and provide a better experience when people have some combinations of modules in their configuration. Yeah, so like I mentioned, the submodules are proper modules, so you can actually use them to do computations on your configuration. So for example, in Arion, we have the service.environment variable, which has all the environment variables for the service. And it needs a tiny bit of processing, well, almost no processing at all actually, but this is actually declared in the service level modules. So usually in Nix packages you see that there's some computation that maps over all the modules, but you can actually move some of this computation into the module itself, and that cleans up the code nicely. So in Arion, each service is responsible for its own piece of the YAML file. One thing I noticed is lists can be annoying to work with. In particular, we've worked with the capabilities in Docker Compose. So with Docker, you can use Linux capabilities. They're basically ways to restrict the security context of a container. So you can disallow stuff or allow stuff. There's a default set of capabilities that a container has. And Docker Compose lets you modify that set. So you can remove things from it, you can add things to it. And so the obvious thing to do is model these fields as lists of strings. But that's a bit annoying if you have a service that splits into modules. Because combining those lists is not very obvious. What do you do if one of the modules says this capability should be removed, and the other module says it should be added? So changing that to an attribute set makes it much easier, because then the module system takes care of this. The module system lets you use priorities to override like lower priority definitions. So this makes for a nicer interface. Yeah, and while developing the system, yeah, I noticed that it's when you're constructing a new system, it's best to start with the low-level stuff, and then whenever you need something on top of that, you can do it in a separate module. So I really recommend to do so. It's easy to add things to a new module, but that can turn into a mess. Yeah, so in the future we'll be looking at integrating better with Flakes as they evolve. We're going to improve the image support, and we're looking into caching the evaluation to improve performance for commands that don't need to rebuild. And we're thinking about how to deal with more distributed applications of the module system. And one example of a sort of an experiment we're doing is project.nix. It's really not ready for prime time, but basically the goal is to standardize the glue code that you find in many projects. Like how do you override the Haskell packages or all those kind of things. It's nice to have options that have a nice definition and can be reused in language integrations. Thank you. Any questions?
So I'm not sure if you touched that in the introduction because I wasn't here, but how would you put that into production? Like, of course you have a Docker Compose setup, but is this Docker Compose YAML like distributable, so you can use stuff like Docker Stack to put that into production?
Right, so we don't have a complete deployment story yet because we're not using this for our production services. So that's kind of a question we also have. Docker Compose is a front end to both Docker itself and Docker Swarm. So at least in theory, it should be easy to actually do a Swarm deployment using this. So that's a way to go, I guess. And the way you wire it up into your deployments, I think that really depends on the technology that you're using. So yeah, can't say much about the specifics of that, but it's definitely feasible. I think it's not a good idea to use the host store on a production deployment. It's better to use the image support that's built into this. We haven't used it with a registry yet. We've only used Docker load. So I don't expect any problems with pushing to a registry, but we just haven't done it yet.
So my understanding is that we need some kind of front end in Nix expressions to describe how we create a cluster of containers with services or systems with services, and then some back end to generate the YAML file. I haven't used it too much, but my understanding is that NixOps has some representation for describing such a cluster and then various backends. Did you consider adding a backend to NixOps to generate Docker Compose YAML files?
Not really, to be honest. And I think it's been worthwhile to take another approach. There's some overlap between features that are provided by NixOps and Docker Compose. So Docker Compose basically has all the state in Docker, whereas NixOps needs an extra state database. So it's actually nice to avoid that complexity. Yeah, I think something similar can be done for NixOps, but it's probably best to take a different approach there because it's just structured a bit differently.
Hey, what is the story about garbage collection routes and how much space will it occupy and how to clean up?
Great question. Currently, it's using a temporary garbage collection route for the duration of the command. So when you run Docker up without any other arguments, that's sufficient because it's only running as long as the Docker up command is running. But when you're using detach, the command will terminate while the deployment is still up. So in that case, you technically have a risk of garbage collecting a live deployment. That's not great. For our purposes, this has not been a problem. But if you deploy, I think that that's one of the main reasons to go with images rather than using a host store. The images will not be garbage collected. Yeah, that said, I think I mentioned evaluation cache. I think it's a good idea to change Arion a bit to be more aware of where things are deployed, so we can both create a garbage route for that deployment on the user system and reuse the YAML file to speed up commands like Arion logs, for example, so that it doesn't have to re-evaluate the entire deployment either. So that will also improve the garbage collection situation.
Okay, so if that's all the questions, okay, one more from Domain before lunch.
Yeah, so I just wanted to, well, it's not a question, it's an answer for Franz. So the reason what we are deploying to Amazon and what Arion gives us is that we can share the module system between what Amazon runs and what runs in the Docker. And that's the biggest addition here, because the Docker is just well, runtime protection system in that case, and it takes care of port sharing and all of that. But we're essentially running the same kind of process and the same kind of configuration as on the machines then. And that's a nice thing of reusing the module system, yeah. So, yeah, that's it. Thanks.
Thank you, Robert. And
thank you.
The lunch is in the back there.
silence and your full attention. And hi, so I'm Samuel DR, Samuel Dianriel. You might more recognize this avatar than my name, I hope, maybe not. And I work on mobile NixOS. What's mobile NixOS? Mobile NixOS is a Nix distribution, normal Linux distribution for your phone. Well, some conditions may apply. The goals are with integrating an heterogeneous ecosystem, which means different kind of phones, different lineage of phones, and all of this in one repository. And its goal also is to make full use of the hardware. This means calling, SMS, data, acceleration, everything, since if you can't call from your phone, it's not a phone, it's just a screen. And then if you can't use the internet from your screen, it's just a useless screen. Then it should work like NixOS and work with NixOS. I think it's easier to start with some things that I don't aim to do right now, or maybe not ever under the project name. Like, I don't want to prescribe any kind of graphical environment. So, just like with NixOS, you're free to choose whatever you want to run as long as it's packaged, and if it's not, then come and contribute. I don't intend to make it particularly easy to run Android apps, but it's just something that can be done via software, since there's projects like Nbox that already do this. Then, porting devices to mainline Linux. I know it's not nice to say that I don't have a goal to port devices to mainline Linux, but it's mobile NixOS that doesn't have this goal, because I think it's a fun side project that's probably going to happen for at least those that I can try it on. Let's start with some history. In June 2018, that's when I made the first commit, and it's also when I announced the project on the discourse. In July 2018, I had a second device ported. This is nice, since this allowed me to check if there were some bad assumptions in there, some, but not that much. And then from July to November 2018, I got busy releasing NixOS, the 1809. Then an uncomfortable long pause. January 31st, 2019. There was a post on the discourse from Armin introducing the NGI 0 on the the post was on the discourse. So on January 31st, I wrote and sent an application for a grant, and the deadline was the 1st of February. So didn't take that much time to write up. More on that later. I was selected for second round. This is good. And in March, I received some questions from NLNet. Turns out my application was too narrow in scope. They wanted me to expand the scope and thus expanding the grant. So I did, and after back and forth, the project was accepted in April. Then, the more important bit for me, it's that in August 2019, I left my job, and now I'm working full-time on mobile NixOS. The current state. Right now, we have 3 devices booting mobile NixOS, and I think I didn't hold power long enough on the other. I hate phones. Then I know it's just way too small to see, but it's just for flair. There it is. It's booting on 2 different devices, and those devices, there's the Asus Zenfone 2 Laser. It's the one on your left. It's much older than the other devices. The Zenfone 2 Laser is pretty much in the first or maybe second round of AR64 devices for Android. And the Xiaomi Redmi Note 7 is the one on the right, which is fun since it's pretty new. It released, I think, in the beginning of this year. So this allows me to just check that, okay, this works on both old and new hardware. this is just amazing because it works on old and new hardware. The OnePlus 3, I don't have it with me, but this one was just trivial to port. It's probably about in between in terms of age, but about 3 hours since I received it in the mail, it was already ported and booting just to the same state as you can see, maybe, I hope, probably not on those phones. I have other targets like the Asus CT100. This one is interesting since it's not an Android target. This is a Chrome OS based tablet. This allows me to test whether I made assumptions that were only for Android based, for Qualcomm based Android devices even, and turns out not much, and I added the target, so I've got an example for 2 different kind of targets. There's the Google Nexus 7 2013. This one is special since it's the second device I ported it to, but it's not AR64. Since it's not AR64, as with standard NixOS, since it ends up being a standard NixOS system once booted, there's no binary cache, so I did not test stage 2 yet, but I have strong assumptions that it's going to work once I've got a full build of the stage 2 working, not working, but building. Motorola Z Play. This one is not working entirely, but it's, you see there's a DD after work in progress. That's because it's my daily driver. I can't spare the phone for now to test. So this one is currently yellow, but it might stay yellow just as the Nexus 7. This is because Motorola, they are not alone in, as OEMs to do this. They release an AR64 device with a 32 bits, so ARM v7L userland. So depending on how access to hardware works, like Wi-Fi, and maybe not Wi-Fi, but probably some other hardware, it might not be possible to run a 64-bit system using the proprietary bits. Let's see how it goes. Then there's the Google Pixel 2 XL. This one is just work in progress since I don't have it on hand anymore, but I was able to get one for a couple of days and just work, and it's almost working. There's just one little bit and might be trivial to fix. And AQEMU VM. This one is not AR64. It's used mainly to test the system image generation and check the graphical applications, since you don't want to first build for AR64 and then transfer it to your phone, and this takes quite a while. So the VM is for developers to develop applications. So stuff that's currently work in progress, meaning hacks I'm currently using to make it boot. The kernel is built in and without model support. Built in means it's built into the boot.img file that's flashed to the boot partition. More on that on why it's an issue soon. And without module support, it's not much of an issue. It's just way easier to start porting when you don't have to bother with module resolution. Is it loading the right modules in your custom stage 1 that you currently can't access via serial, since there's no serial access on most phones. So you always boot the current generation. That's another hack. You can't choose the generation at boot. There's not some of your usual grub or system deboot or anything as a bootloader. It's ABL or aboot for the Android devices. This means that there's no choice for the generation. So if you make a small accident with your NixOS rebuild switch, you might need to reinstall for now. But that's just for now. And there's limited hardware support, meaning that there's not much of the hardware working. There's sound lacking, which might not be much of an issue to fix. There's Wi-Fi not working, but everything is known. It's just I've been lacking time to finish working on that. There's no GPU acceleration, but I've got a contribution which might do all that already. And there's no cellular communication, so no calls, no SMS, no data. And then there's no proper phone interface. What I mean by that is there's no like Plasma Mobile or Fauch, or it's just your usual X11 desktop, which well, it's not made for touch, even on a real big screen like a tablet. So it's all room for improvement. So let's see how I'm going to improve. I'm going to write documentation. I know it sounds weird, writing documentation, but it's important. So the basic structure, so you know how everything is put together. Then a porting guide, since currently the only way it works for porting is I try to port to a new device and I see, oh right, I fixed that on the other device by switching which options, and that's not a great guide. And then a list of devices and their status, just for when you're going on the NixOS website, you've got a list of devices and their status, same thing, and a website tying this all together. I know this is not the fun bit. I need to work on enhancing the boot process. There's a couple of steps in there. First, selecting a generation. This is quite important and inside the DNA of NixOS. We probably need to key exec to another kernel, since switching kernel is not easy, and ideally I'd like every generation to list which kernel they use exactly and treat the boot IMG just like it was a bootloader. Then there's a strategy for a virtual keyboard during stage 1 that's needed, since you don't want to break out your full USB keyboard and plug it in through a USB adapter to your phone when you're rebooting it, since it crashed for whatever reason, maybe not mobile NixOS's fault. Then enhancing the boot progress reporting, since right now it's just an image telling you it's stage 1 and then another image for stage 2. It's probably better if we have some output like it's currently doing this thing, this thing, this thing, this thing. All work in progress. Then we need to make more things work, like sound, GPU acceleration, Wi-Fi, and everything cellular. Phone software. This is not about phone environments, it's about telephony software. I don't think there is much package in NixOS right now, so just taking time to do this. And then about a phone environment. What I mean by that is just like DEs, WMs, DMs, you all know what this means. Then I want you to know that PE means phone environment. Let's continue with questions I already know you have in your mind and you want to ask me. What do I need to port? What do I need to port? You need first an unlockable bootloader and also to have unlocked your bootloader. It's not enough to just have one that's unlockable. And then kernel sources. I did write for a speedy port. It's possible without the sources, but it's going to be an uphill battle. How can you help? You can help by porting to new devices. That's like the first way. It's probably the best way to help, since there's so many devices and so many hours in a day. Then you can test with the devices you own. If you already own one of the devices listed previously, or one of the devices that's going to be listed in the future, you can just run it, hopefully. Then packaging software. This could be done without even any mobile phone. With the QEMU VM, we some work on some of the parts of the stack, most likely the phone environment, some of the software, testing that things work as expected. This can be done without even having a phone that's supported. Other things you can do to help? Well, talk about it. Not only talk about mobile NixOS, just forget about it for 1 minute. It needs to become ingrained in everyone's head, maybe not the normal people, but every geek that has a phone, that it shouldn't be normal to want to run another mobile operating system. I'm not saying necessarily a GNU Linux distribution. It should be normal to even want Windows on your phone. You probably don't want it, but it should be normal to want to run whatever you want on your phone. And this is not something that we can fix. It's something that can be fixed most likely by the OEMs, but even then, most likely by the manufacturers of the CPUs, the system on chips. So let's try and make this an issue that's known, and that, anyways, I most likely will not buy a phone where I can't control the boot process from A to Z, And another issue, phones where it's easy to break by accidentally flashing to the wrong partition. Oh, I didn't skip anything. Then this is all something that's to be continued. And now I'm ready for your questions, hopefully. Ask me anything, we've got some time.
Hey, how many phones have you bricked while trying to run this?
Can you repeat, please?
How many phones have you broken?
None. But it's the easy way. You don't have much risk as long as you don't flash the bootloader, the one bit before Linux. If you only flash the bits on your Android phone where Linux resides, it's, as far as I know, like 99.99999% safe. I don't want you to come to me when you break a phone, but I think that as long as you don't flash stuff to partitions you shouldn't flash stuff to, it's going to be fine.
I have a question of my own.
Yeah?
So you still keep the original kernel in place and the new exec, or do you even replace the original kernel?
Currently, right now, it's building the OEM-provided kernels. Why? Well, the reason is simple. Everything already works with that kernel. The Wi-Fi, the cameras, the sound, everything is supposed to work with this kernel. Then, this kernel could get updated. Some projects already update kernels from Android OEMs. So what I like is that there's always going to be the boot.img kernel that's going to be a stable one that you trust, one that you've built and you know works, and then you're always able to just kexec into a new kernel that might be mainline, hopefully be mainline, and where you're working on porting it and bettering the whole Linux ecosystem.
If I have a Lineage OS device which has all your checkmarks checked, how much hard work and sweat separates me from booting NixOS mobile? Like days, weeks, months?
Your first port, maybe a week, depending on if you're lucky, if the phone is trivial to port to. But when you're using a phone that's already well supported with Lineage OS, in my experience, it's much easier since everything is like listed already in the open. Other phones to port to are phones where there's only the OEM source dump and no community yet, like the Redmi Note 7 right here. Fun story, that's my first Xiaomi kernel. First Xiaomi phone, first Xiaomi kernel from their kernel open source kernel release. It would not boot, not at all. I finally figured it out since during this time some other projects were porting it. And then when I found out which option I was lacking, I searched online what this option was doing, and it's documented in the wiki of the project. So basically, read the docs.
So when you use the kernel sources from the OEMs, can you reuse the Linux builds that we use in Nix packages, or do you have to write your own build files for that?
When a device gets ported to mainline, then generally it will mean that you can use a normal kernel. But until then, you're going to need to build a kernel specialized for your phone or maybe a family of phones. Is it the right answer, the right question that I answered? Okay.
So if you're using the OEM's kernel with their modules and drivers, which would support the hardware like LTE, what is the challenge to get those devices working?
Can you repeat the end of the question?
What's standing between you and supporting the devices like sound and modems?
For porting to mainline, the main issue is that most of the times the OEMs just drop horribly atrocious code to just make it work. And so it just can't be ported forward. Sometimes there's also breakage in the kernel APIs, the internal APIs, and it's always It's normal, it's to be expected. They never said that a kernel API is stable. It's the kernel ABI for userland that is stable. So that's one main issue. And then about just porting to this kernel to work on mobile NixOS, no issues. That's exactly what we're using. We're using the OEM dumps to get started.
Perhaps one more question.
All right.
Have you looked at packaging what Jolla have as their UI, the continuation of the Nokia operating system?
Can you repeat, please? I didn't hear you.
The Yola operating system, the Sailfish. If you have looked at packaging those things, because I don't think they're going to be extra friendly to packaging outside of their distribution.
Currently, I'm not working on anything else than a standard GNU Linux distribution. So it should be possible, just like everything is possible with enough time, to make the whole Sailfish OS build with Nix. But it's more Sailfish OS, even though it's more GNU Linux than Android, is still like its own OS, like just LeonOS, which is the open source port of WebOS, is its own integrated operating system. So just taking bits from them sometimes is harder. So it should be possible, but it's not a current goal due to lack of human power working on the project. But maybe in the future we will.
Any more questions?
Would you benefit of us giving you our old phones to make them all work on NixOS?
I will benefit if you were to use your old phone to port it to. Not only because I'm lazy, but also because you're going to have a phone with mobile NixOS in your hands, so you're going to be able to test it and maybe file bugs, or even better, PRs for whatever is missing for you.
And the second question would be, for the grant that you got, is it limited to some extent to only to you, or is it possible that in the future you might extend your project to have like multiple people working on that as well?
If I understood what it's about the grant, I'm not perfectly sure. I could ask people from NLNet that I think are hidden in the room, and they will tell me if it's all right, but I think so. All right, so since there's no microphone, the best thing to do is to write a new proposal, which means from myself or something like that.
Yes, so if you have additional features that you would like...
Yes, it is.
If you have additional features that, or additional phones that you would like to help, which are maybe not as large as the stuff that Samuel is doing right now, but you can also ask for a fairly small grant to help.
Well, that's the question answered.
And if you want to do a whole desktop, which would be a larger thing, that's it's all fine with us.
Well, it was fun presenting to you. Have a nice day.
Thank you, Samuel. The next talk is from Nicolas Mattia, and it's an overview of language support in Nix. So let's start.
Hi, everyone. So thanks for coming. First of all, a bit of background. I started using Nix at work about 3 years ago, and I was suffering from Nix a bit. I was a bit of a Nix hostage, but then 2 years ago went to the NixCon in Munich and kind of opened my eyes. So I'm still suffering now, but I got a bit of a Stockholm syndrome, so I'm enjoying it. So the talk today is about language support in Nix. It's going to be I'm trying to make it not tied to any language in particular, but I have a background in Haskell and now a bit of Rust, so there might be a few language-specific things. And it's going to be in 3 parts, basically. The first part is going to be the basics, just so that we all agree on the vocabulary and what's happening, what's a compiler, what's a build tool, the difference between the two. And then the approaches. So the approaches that are used in Nix packages and elsewhere nowadays to actually package Nix code, or package language codes in Nix. And then the last one is going to be a bit of an overview and a few takeaways from what's right now, where we could go in the future, and the best approaches. So let's start with the basics. Enter the matrix. We're going to kind of articulate everything around a few axes. So on the left hand, we have the fixed output derivation, cogeneration, log file based, and pure Nix. These are all general approaches used nowadays. And we kind of try to mix them and match them with 3 key aspects, or 3 metrics. The first one is the UX. So how easy is it to use any of these approaches? So does it just work? This is very important most of the time, because if you want to build something, you want to package something, you want it to work. You don't want to have to debug it or figure out new flags, and you want it to just work. And the second one, which I think is important, is it consistent with the user workflow? That is, if your user is using, for instance, Cargo to build Rust, or Cabal to build Haskell code, is this build going to use the same tools, or is it going to be some special mechanism that's going to try to recreate the logic? So ideally, it would just work, and the result is the same as using the native tools. Then the big problem in Nix in particular is incrementality. If you change a single command somewhere, are you going to have to wait an hour for everything to rebuild? Incrementality is about making builds as short as possible when possible. And this is usually handled by the build tools themselves. They do it pretty well. But in Nix, it's always a question, because you have this derivation, which is, okay, here's the log step. If you change any input, then the whole derivation is going to be rebuilt. So we try to make the derivations as small as possible for incrementality. And then the evaluation, something that's not really talked about much in Nix, but it's basically the row overhead that Nix brings on top of the build tool. So it's all the Nix evaluation that happens before your code or your build code is actually run. So for instance, if you have Nix packages, Nix needs to go through everything, evaluate the packages, and be like, okay, I'm going to pull this one, I'm going to pull this one, pull this one, and then it's going to tell you, okay, I'm going to fetch this, and I'm going to run these commands. So the evaluation is the first step. So the first and simplest approach, vocabulary first, my bad. We're going to talk about compilers, build tools, and that's pretty much it. The compiler is the thing that actually compiles your code. This is something that you can't get away with. The build tool is the thing that kind of puts the pieces together and calls the compiler here, forwards the build outputs there. And sometimes you can actually get rid of it in Nix. We'll talk about it more later, but the compiler is something you never want to re-implement in Nix, whereas the build tool, as we'll see, it's possible, even though it might not be nice. So let's go with the approaches. The very first one is the fixed output derivation. If you don't want to spend any time thinking about it, you do that. So you run a command. Your command can do anything you want. It can call network. It can fire missiles, everything you want. And you just kind of tell Nix, hey Nix, listen, the output is going to have this hash. Trust me on this. And if the output actually has when hashed, gets the exact output hash, then Nix is going to say, fine, I'm going with you. But so even though it's the simplest to implement for anything, it has a few drawbacks. The first, evaluation is super fast because Nix doesn't have to do any job. It just checks the checksum, and if everything is good, fine. There's no special logic there. Incrementality is pretty bad because whenever you change anything, you'll have to rerun. And I'll go more into that in a second. But the UX, for me, is the worst. Because what happens is that whenever you have a single input changing in your build, so for instance, your user adds a dependency for a Node.js program or anything, you're going to have to change the hash by hand, the checksum. And it gets even worse if you forget to change it, because Nix is going to just look up the hash. It's going to be like, oh, I already have this in the store, so fine, your build is fine. Even though in practice, it would generate a new build with new build output. And so the question is, can we improve this so that you don't have this huge lockstep and this huge fixed output derivation? And you can say, well, most of the time the local code changes. When you edit, you might add a function, change some things, but the dependencies that you pull in, those rarely change. They change maybe once a week or once a day, but that's not too often. So this is something we're going to look at in a second, but first a few warnings. So Nix is not meant as a content addressable store. So when you have those hashes in a Nix store, they're based on the inputs of the build, not the actual output. And so using the hash as a key is kind of against the Nix model. What's very dangerous is that you have to trust a lot of things. First, you have to make sure that you didn't screw your build phase, that your build phase is always going to call the same functions, they're always going to run the compiler in the exact same way. Then you have to trust the remote content. If you're pulling dependencies from somewhere, you have to make sure that the URLs that you use, they're always going to give you the same bytes. Otherwise, your build is going to change. And you have to trust compiler reproducibility. So if your compiler decides to generate different outputs depending on the day of the week, for instance, as GHC did at some point, then you might have something that works for you, and then you give it to your coworker. You're like, hey, here's this Nix code. It's gonna work just fine. But at the end of the day, their code is going to be different. The generated output is going to be different. It's going to have a different hash that doesn't match the one that you put. And so your coworker is going to be angry at you, and this is something you don't want. So about those dependencies. No, not dependencies. So another approach where you don't use the fixed output derivation is that you just run some external tool that pulls these dependencies for you and compiles the hashes for you. This is an approach that's used widely in Nix. It's the foo to Nix. So you have stack to Nix, PyPy to Nix, yarn to Nix. And in this case, you have a tool like Bundix for Ruby that you call, and it just generates Nix files for you. These Nix files, you then import them in your code and use it. But there's a problem, because first, you have to check in all this generated code so that everyone uses the same. So in terms of UX, it's not very good. Then that means that you have your Nix build for the build. You might have an NPM build when you build locally, but on top of that, you have an extra step that you need to run every time, which generates this Nix code. On the other hand, the incrementality can be good. It depends on how the generated code works. Sorry, I'm stumbling a bit. And the evaluation time depends also a lot, because it depends on the generated code. So all these for me are not ideal, because you have this big Nix code that was generated, and we're in a time where most programming languages actually provide log files. So the log file actually tells you, hey, this is the URL of this dependency, here's the SHA for this dependency, and maybe in order to improve on this terrible UX, we can actually use these log files. And this is the next approach I'm going to present, which is a bit of a self-plug, because something I've been doing a lot lately. And the focus is really user experience. So ideally what you want is to have a single function that you call on some source or on some project that has a log file, and the build just works. You have nothing else to do. So NERSC is one I wrote for Rust, and I think Elko did something similar as well at some point. And Napalm is for JavaScript, of course. And so as you can see, just load the library, or say it's in Nix packages, you just call the function, and everything just works. Now, how does that compare? Oh, how does it work first? On the left, you have an example log file. That one is a cargo log file, which is TOML. And as you can see, you have the URL, where cargo is actually going to grab the dependency from, or the raw code. And it also gives you the checksum. So technically, Nix would be just happy with that. And indeed, so when NERSC works in a cargo project, it's going to generate in memory, so it's not going to generate code, but it's going to generate something very similar to this. So you have a make derivation. You tell it, hey, the URL is this, the SHA is this, and Nix is going to be, okay, I'm going to pull it, download the dependency, checksum, everything is good, and there you go. There's no code that's being generated. So the problem here is the evaluation, because you have Nix, you're asking Nix to parse JSON if it's a JSON log file, TOML if it's a TOML log file, and this can actually impact the evaluator quite a bit. You might have, well, long-running evaluations before which Nix builds any code. Incrementality is okay, because most of the time you can get away with having per dependency incrementality. So if one dependency changes, then Nix just repulls this one. If you do things well enough, it can even build the dependency as opposed to just grabbing a source code, and then you don't have to rebuild any dependency that wasn't affected. And in terms of UX, it's basically the best in class, because when you have a new user coming, you tell them, hey, just do Nix build and it's going to work. If you change code, fine, it's still going to work. If you add dependencies, edit the log file, fine, it's still going to be the same dependencies that you used when running cargo, for instance. So this is very good, but incrementality is still kind of lacking. It's just okay. So if we go now one step further, this is what I call the pure Nix approach. And this is something I experimented with in Haskell in particular. And the idea is that you don't have per dependency incrementality, but you have per file. If you modify one file, just this file is going to be rebuilt. If this file is dependent on by other files, okay, then these files are going to be rebuilt as well. But generally, you don't have this big, oh wait, I have to wait 3 minutes because I changed one comment because Cabal has to rebuild the whole dependency. And it's kind of magic, but actually in practice it works pretty well. So on the left, you have some kind of description of a build where you say, okay, this is my source, it's in this folder, I have a main module, and I have some dependencies. But what Nix is actually going to generate, or what Nix is going to run, is something similar to this, where, by the way, the clicker doesn't work, so I have to use my finger to point. I hope that's okay for you. The important part is that this make derivation, okay, in the name, you use the module name. That depends only on the module. Then you have the build phase. Well, you have the module source, which is the path to, for instance, a Haskell file. That depends on the module, then the module name again, fine, and then the build depths. So it depends only on the module itself and the module dependencies. So nothing else. And then you kind of bake together the top module, so you create a graph of all the module, a dependency graph, and you just link everything together. If one module changes, only a specific path in that graph is going to be changed and it's going to have to be rebuilt. But the rest, all the other modules, all the other object files are still going to be there and you can reuse them. This is fairly nice because you have basically the same level of incrementality as Cabal or Cargo outside of Nix. Now, there's an evaluation problem. I wrote Snack about a year ago, and a few months later, a company approached me and said, hey, I really love this Snack thing. Like, this is really the right way to do stuff. And it works, actually compiles. We just have a single problem. The evaluation took 7 days. So I never dove too much into how the Nix evaluator works. I'm not very good in performance work in general, so I believe this is fixable, but by someone else than me. But in general, this is the big problem, because you're delegating all the work to Nix. Nix is an evaluated language compared to, for instance, Cargo, which is just built in Rust, so it's all machine code, just checking the M times, checking the checksums of some files. So now everything happens in Nix. On the other hand, incrementality is best in class. If you think about it, for a Haskell, oh, by the way, how many Haskellers do we have here? Okay, this is beautiful. Incrementality is even better than that of Cabal, because in Cabal, if you have a Cabal library where you change a single file, and you depend on that library, well, Cabal is going to decide, I have to rebuild this library. Whereas in Snack, it's just going to look at the module dependency, and most of the library won't be rebuilt, especially if it's a top-level file. It's just going to recompile that file, and then only your files that depend transitively on that file. So this is kind of beautiful. How's the UX? It's complicated, because the way Snack works is it's basically a big Nix library and a tiny executable around it. And the executable itself calls Nix build. So UX is pretty good if you get the executable right, but there's some cost, because then your engineers need to learn how to work with Snack. You can't tell them, oh, use Cabal, because Cabal is just not going to work there. So you have to teach them a new tool, and you basically have to get it right, which I did in Snack. So we have all these approaches that go from something very coarse-grained when you had the fixed output derivation that just rebuilds everything, and then maybe you can just abstract away the dependencies, have these in a fixed output derivation, and then rebuild your local projects much faster. Then we had the generated code, then we have the log file based, and then we have the pure Nix approach. So they all have different trade-offs. Some are good, some have fast evaluation, some are incremental. And we basically have this. So in terms of, for the fixed output, the UX is terrible, once again, because you need to change the hash whenever anything changes. Incrementality, ouch, bad as well. Evaluation, on the other hand, is fast. Fixed output with depths, it's pretty much the same, except that you have better incrementality, because the hash changes only when any of your dependencies change, but not when your top-level project, the one you work on locally, changes. And evaluation is still fast, so that's good. Code generation, UX, once again, is pretty bad, because you have to rerun an external tool whenever you have a change in your code. Incrementality, depends. Depends how the generated code works, depends on many factors, which might depend on the tool. So if it's stacked to Nix, it might be good. If it's Bundix, it might be bad. It might be the other way around. Depends very much. Evaluation is pretty much the same. For the log file, UX is great. You have the same commands that run as in Cargo, but in Nix. Incrementality is okay, depending on how you code it up. Evaluation is slow. And the pure Nix, once again, UX complicated, because you need to build new tools, and incrementality is amazing, but evaluation is bad. So the main takeaway here is, well, Nix doesn't work, right? We can't have all of them. We can't have the cake and eat it. So what do we do? There's actually a more interesting question, which is, well, maybe we don't need to have a single approach for everything. And maybe we should split the approaches by users. So for instance, we have a newcomer, someone who's just discovered Nix, actually like it, is actually interested in using Nix. And well, for him, it should just work, right? Because you told him, hey, it's gonna just work. But then that person might not care very much about evaluation time or incrementality. They're gonna try Nix build. It's gonna build their huge Java project that they never managed to get compiled before, and they're happy. Then you have the power user, which I think is most of the people in this room. You really like Nix, and you don't mind adapting your tools to Nix. You don't mind writing wrappers around Nix. You're happy with anything, but you use it very, very often. So that means that evaluation and incrementality must be very good, because Nix then becomes your primary tool. And then you have a different user, which is not a real user, but it's a machine user, I'll call it, which is the packages that are in Nix packages. These are usually not built by hand on your machine. They tend to be cached. The problem is, for evaluation, for instance, if you pull or if you evaluate Nix packages, you want this to be fast. You want it to be extremely fast because you're going to be evaluating tons and tons of packages. You might have 400 dependencies for your single local project. So this step, you want it to be extremely fast. The rest, you don't really care about it. You might have bots that generate code that's then checked in Nix packages, but that's fine. You, as a person, don't have to care about it. And then you have the Nix hostage. The Nix hostage is the guy at your company who you told, Nix is going to be amazing. Let's use Nix. And this person needs perfect UX because they don't want to care about Nix. They want fast evaluation because you told them, yes, of course, you can use it as your primary build tool. And it needs to be incremental. Otherwise, they're going to complain about CI, which they usually do. So, can we kind of have all this? Well, there are kind of tensions. Incrementality, for instance, most of the time you require build tool knowledge. So if you want to have per dependency incrementality, you need to know, for instance, how NPM works. How does it actually insert dependencies in its cache? If you go with the extreme of the pure Nix snack-like approach, then you need to know even how the compiler works and what flags it accepts, how it's expecting its dependencies, or the pre-built object files. And then the more incremental you get, the more you're going to get the evaluator to work. So this is something you gotta really care about. And then you have these Nix hostages that need the best of all possible worlds. So maybe we should have a multi-tier approach in Nix packages and elsewhere, where you could have Nix packages that has some very fast fixed output derivation-like builds, and then you might have a log file, like a snapshot of all dependencies that you can choose from, and it's going to be whatever tool you use is going to read that file, check the checksums, and then build all your dependencies using that, but only the dependencies. And then for your local build, you might have something that's very pure Nix-like. So this is pretty much what Snack does right now, and I think it's something that we rediscovered recently with Bazel, where they have dependencies that come built with Cabal. They use the stack-age snapshot, but then for day-to-day users, you only rebuild your packages fast with built-in Bazel primitives. And I think this is something that's quite interesting. Even more interesting would be if we could have that without the user knowing about it. So maybe you could have 2 or 3 different mechanisms that kind of switch. If Nix realizes that this is a dependency you don't use often, then it's going to push it back. It's going to use the more fixed output derivation-like builds. And if it's something that you change regularly, then it's going to use the pure Nix implementation. So this was pretty much it. But there's one interesting question, which is, can recursive Nix help with this? So I'm going to let you read the code for a second. That appeared on the GitHub issue for recursive Nix. What it says is basically, so it's a statement, but any solution that the incremental build problem that involves the build system is going to be brittle, which is very true. that's what happened to Snack. And it's going to essentially re-implement the logic of any build system in Nix. And once again, Nix is evaluated, it's slow, and yeah. So this is not something you want to do for every language, or if you want to do it, you got to spend a lot of time and resources on it to make it work right. And now that we're talking more and more about recursive Nix, and that I think the implementation is coming, you could have Nix as the new Ccache. So Ccache is a speed up for GCC or any GCC-like compiler, where if it realizes that the arguments have already been used in a present call, then it's going to say, hey, wait a second, I already have the build output somewhere over there, which technically is what Nix does, right? Because Nix will hash all its inputs, and if all this happened already, it's going to say, yeah, reuse this derivation that was built X days ago. So maybe recursive Nix would be a good solution for this, where say you have a build tool like Cargo or Make or anything like that, and you kind of lie to it. You say, hey, Make, instead of calling GCC here, just call Nix. And you have this in your Nix build. And basically, when I started the talk, I said, well, the build tool is something we can emulate in Nix, whereas the compiler is something, it's a given. It's not something we can get rid of. Maybe with recursive Nix, we kind of can. We leave the build tools to actually drive the builds, but we plug in Nix as the compiler. If Nix doesn't have the derivation pre-built, then fine, you recall the compiler, but in general, most of the time, your object files are going to be just fetched from the cache. And that's pretty much it. Thank you for your time. Any questions?
Hey, great talk. So, what do you think about the? There is a code gen option, right? But I think if you start using import from derivation there, you kind of gain the UX back in that option. Have you considered that?
So you're saying that if you use import for derivation for directly importing Nix code, then you don't have to check in the generated code.
Yeah, and you don't have to do, so Haskell.nix is essentially that approach. I think the talk is tomorrow, so. But I think you get good UX and you get semi-okay evaluation times, again, depending on what you're doing.
Yeah.
So I think it's the sweet spot, but of course all the incrementality is not there.
So I think this one is actually, or Haskell.nix in general, is closer to the log file approach. Because if you don't use a log file, then okay, you might generate codes, but you still need to figure out the hashes, right? The checksums. So I think it's different from the code gen that I talked about here. Does that make sense?
Yeah, I mean, it makes sense.
Because you can't use that without any table of hashes that you had before, right? Or log files.
Yeah, I think it's somewhere in the middle. So some things you have the hashes from, like there's snapshots of Hackage and Stackage and all of that. But if it's coming from Git, for example, then you don't have it, right? So it's somewhere in the middle.
Yeah.
Yeah.
I didn't talk about the Haskell infrastructure at all, actually, because it's quite complex. Never really wrapped my head around it. But there's lots of smart stuff there, which wasn't covered at all in this talk.
Okay. I was just wondering if you thought about the IFD. So yeah, okay, cool.
I think it was a question in the back, or maybe it was an answer.
It's a follow-up comment. Haskell and Nix does both. I think one problem with the pure lock file approach is that the build tools themselves don't just use the lock file. They also consult the cargo.toml or cabal file or other thing. So if the point is doing the things the way the tool would go from the plan, I think you do need to ingest both or lobby them to work differently upstream, pick your poison. But yeah, I think the IFD should help a lot, and if you do enough little ones, it should even be pretty good for the evaluation incrementality. So fingers crossed.
Yeah. Thank you.
One point you really have to keep in mind when you do dynamic recursive Nix with dynamic dependencies that you, like, while evaluating the tree or the graph of what you have to build, you don't know everything in front. So you have to generate parts of the graph while you are building, because you have to build something. And IFD already does that, but it has the restriction that it can't access network while doing it, right? So you have to check in the log file and then maybe generate Nix code on the fly in the build and then evaluate that. But you really have to be careful, like what you require from the generated graph you want to generate on the fly. I think the best of all worlds right now is to do this, integrate the package managers and use the log files. That's like the best approach. But really need to go upstream and nudge the package manager creators to produce log files that we can actually use, because, for example, for Yarn, sometimes there's only a Git hash of a Git ref and no output of the Git repository, so you still need network to generate the Nix file again. So that's...
Yeah, completely agree. So it seems to be a trend in build files or build tools to not output a Git hash or hash for Git dependencies. And I completely agree. We need to find a way to tell build tools, hey, please guys, some people might actually need this, and maybe as Nix grows and becomes more used widely, then we're going to have more ways to actually convince them to add checksums pretty much everywhere. Yeah, that would be ideal.
I want to just say I think that's already happening. I think that, I mean, we do see build tools doing more. I mean, Cabal now is calling itself Nix style, and I think that the value is clear. And as Nix gets bigger, we don't have to do everything ourselves. People will build tools that integrate better with Nix, and I think that's a good avenue to approach.
Yeah, in the particular case of Cabal, I think they went the wrong direction. Instead of making it easier for Nix to use, they kind of grabbed the ideas from Nix and messed up their UX at the same time. That's unrelated.
So you mentioned that evaluator performance is often very slow. Did you do any investigation into whether there are easy speedups for this?
No, but some people have, and there are a few people here at NixCon. So I think they're mostly low-hanging fruits, because I think it was the case in Nix packages and a few other projects. So this is not too much of a worry for me. If we're getting to more pure Nix builds, where Nix actually replaces the build tool, I'm pretty sure there are solutions to the evaluation problem.
So a follow-up question to this. In most languages, compiling an individual translation unit is generally very fast. So tools like Ccache have this constraint where it is often more expensive to determine if the cache has something that it can replace than it is to just compile it with GCC for most translation units. Do you think it's feasible to get the Nix evaluator to be so fast that it is close to as fast as Ccache at determining whether it has a translation unit replacement?
I have no idea. But it's even worse than that, because every single Nix derivation, especially if you build in Sandbox, there's a lot of infrastructure happening. First, setting up the Sandbox, and then only kicking in the build. So yeah, these are all things we should keep in mind if we're going to get something that's close in performance as Ccache.
Great talk. As a fellow
Thank you.
Nix hostage, I also thought it was a bit of a scary talk, but I have a question about the pure Nix solution, because if I understand correctly, does this mean that for every object file in your system you get an entry into Nix build? Into Nix store?
Yes.
Ah, lovely. Okay.
This sounds scary at first, but in practice it's not much of a problem. Most of these object files are small, and actually there are some questions there, like can we improve the garbage collector in Nix to make sure that, okay, maybe all these small files, maybe we can tag them as discarded, because if you change a complete module, then you could say, well, these are definitely not going to be used. And a tool like a pure Nix implementation could say, I'm pretty sure I'm not going to need these anymore, so please get rid of them as fast as possible. That would be very interesting, yeah. All right. Thank you, everyone.
was about the EU Next Generation Initiative, and the other way is to get your NixOS project funded from Armin.
All right, thank you. So can you hear me? All fine? Okay, good. So my name is Armin. As some of you might have noticed, I'm probably the only person here not using NixOS. It's actually Fedora. So while we were, so yeah, you can boo me, you can throw things at me, but only chocolate, please. When we were driving here to this conference, Rob just kept saying like, just give me your laptop, I will just install NixOS right now. And I said, just keep your eyes on the road, okay? All right. So let's talk about money, that mean green. So, and how you can get paid for working on an open source project, including Nix and NixOS. So Samuel already talked a little bit about what he did, and I'm going to explain a little bit more about the specifics together with Jos here from NLNet. So this is an interactive talk, so feel free to ask questions. On the other end, I've got quite a few slides, so you might want to ask them at the end. So a little bit of a poll. How many of you are currently getting paid to work on open source software? So there's one. So how many of you would like to get paid for it? So then this talk is mostly for you. So next generation internet. Basically this is something, a program in the Horizon 2020 program, a research program from the EU, and it is about making a more human internet. So that's the blurb that I got from their website, so I'm not going to read it. But basically, you have to see it as reimagining and re-engineering the internet. So currently, the internet, as we know it, is it very much has a Silicon Valley imprint. Basically, its DNA. There's a lot of it just screams Silicon Valley. On the other hand, there is also a lot of stuff going on in other parts of the world to create their own internet. So think of what's happening in China, but also in India. If you're following a little bit of what's happening with the internet in India, it can get quite scary. So what their government is trying to do. So the EU, even though it can be considered kind of big and a Moloch at times, they want to re-engineer the internet, make it more humane, and to get the core values like democracy, diversity, and so on ingrained into the internet to actually make it a better internet. I think so Jos is agreeing. So one sub-project of that is NGI 0, which I will be talking about today. So NGI 0, first of all, it's a consortium with quite a few organizations involved there. I'm not going to run through all of them, but the most important ones, of course, you see there, NixOS Foundation, that's us, yay. And NLNet Foundation, and a whole bunch of others where people are, I thought I had actually I should have had that picture. So there are quite a few organizations involved, things like translations, secure software, packaging, accessibility, you name it. So there are a whole bunch of organizations involved in the NGI 0 project. So I'm now going to, all right. So, but before I can explain what we actually do, I need to talk to you a little bit about what a normal grant procedure in the EU looks like. So the normal process to get funds in the Horizon 2020 program, or any EU program for that matter, is basically like this. You have to form a consortium of at least 3 organizations from various countries or partners from the right parts of Europe. So you get one from North Europe, you get one from the garlic countries, and one from the cabbage countries, and then you're usually fine. So from all geographically nice, so the right parts, you send in a proposal, then you do stuff for a few years, and then you basically throw something over the wall and you get paid. So, and then sometimes it doesn't even compile or even work or do what it was supposed to do. So this is a very process-heavy thing. It's not very suitable for open source because most of us, we like to work in a much more agile way. So, do small projects, fast releases, work on tiny things, and then just move on to the next interesting thing, because that's how we work. But this process is not for us. It's for the big corporations. It's the big telcos, the big industrial conglomerates who actually have whole departments just writing proposals to get money out of the EU. And if you're actually looked at doing one of those proposals, I did. It's horrible. It doesn't work for us. I need to hire something like 2-3 people to actually do that stuff and then have them on a payroll. Of course I will get it reimbursed, but it's a lot of overhead. This is totally not suited for SMEs or open source developers. And it's also not helping the public, because you get something that might not even work. But you know, it fits the proposal. They got money for it, so it should be good, right? So basically a lot of this money is not working for us. And that is something that should change. So NLNet Foundation, basically they organized a consortium, and they tried to see like, okay, maybe we can do something that we've already done for the last 20 years. So NLNet Foundation is a Dutch nonprofit. They trace their history back to the very first internet provider in the Netherlands, so in 1982. That's before most of you were born. So, and then they sold their provider off to UUNet, later Verizon. They got a bunch of money, they formed a nonprofit, and since 1997, so before some of you were born, they've been handing out grants to open source development. So basically, what they are doing is a very lightweight approach. A developer says like, I've got this great idea, sends in a proposal, and NLNet looks at it and thinks like, you know, if you can do this stuff, then we are willing to make a donation to you. And it's super lightweight. Developer starts working, delivers, and then there is a payout after completion of the milestones. And that's just the complete opposite of how the normal EU grants work. And this has been working for a very long time, so more than 20 years. They've sponsored things like DNSSEC, many other things that I don't even remember. There's a whole list on the website. There's a lot of stuff that they've done. So in the background, they've been doing a lot of very good stuff. And also, what's important, they're a registered charity in the Netherlands, and at least in the Netherlands and also in some of the countries, you can actually get, because it's a donation from a charity, you don't pay taxes, which can be nice. So NLNet wanted to bring this lightweight process to the Horizon 2020 program. So they formed the NGI Zero Consortium, and basically then they sent in proposals to the EU, and then they were awarded 11.2 million euro to spend on open source development, which is pretty cool. So and then for 2 themes. One of them is search and discovery, which is basically unlocking all kinds of data, making sure that people can discover their data in some way. So think search engines, IoT, search, whatever. Anything search and discovery related. And then also privacy enhancing technology. So think security. And the EU is also carefully paying attention to see how this will work, because they know that, well, I think that they secretly know that their normal grant process doesn't really work. It doesn't really work for the people in the EU. So they're thinking like, okay, how can we change it? Oh, okay, so the grant program works for some people in the EU, but not the vast majority. So they're thinking like, okay, well, how can we make it work for everyone? So they're paying attention and seeing how things will work out, and then maybe if it's successful, they might expand this, and that would be good for all of us. So Jos told me that around, so as of today, we've been running this for, what 10 months? 1 year? And so a bit less than 1 year, and so far, 4 million euro has been allocated for development in these 2 domains for about 120 projects. And what is interesting is that 95% of the grant seekers, they've never participated in any of the grant programs of the EU before. So or at least in the Horizon 2020. So they are now reaching a completely new group of people that are in need of a grant but couldn't get it or didn't know how to get it or thought it was way too much overhead. So that's a very good thing. So I already shown that one. So, and then of course the role of NixOS in this consortium. So NLnet Foundation, they are big fans of NixOS. We have a history going back a long time, even before NixOS started. Because the current director of technology of NLnet Foundation was actually working for the Dutch Academy of Sciences, and he got and he was the person who basically read Ilko's original proposal and signed off on it. So it is even going back from way before there was NixOS and way before he was working for NLnet Foundation. So there's a very long history, which is cool. So and they really like NixOS. They think it's fantastic, and of course it is. And they are convinced that things like deployment of software and to make it easy would be very essential to make this project work. Because normally they would get something like, yeah, you know, to run this software you need to run this specific version of Ubuntu with these packages and maybe that patch. Or another component, you need to have SUSE with these packages installed and that out of tree stuff. And they thought like that's just too cumbersome. That will never ever work to make it agile and to make it a smooth process. So the ideal is that when a project comes in, that we help them with things like packaging and software that, and then the software could be demoed and would be like that. Just run Nix shell or Nix build and then just run it and then it would work. That's the ideal. So that's why we are involved. So we've been giving funds to help with things like packaging the software in the projects that are coming in through NGI 0 and also to improve the NixOS infrastructure itself to help with the packaging as part of NGI 0. So we've been giving some funds. We can choose to spend them as we like, as long as they fit within these two categories. So then, of course, the question is, what can you do? One of them is that you could send in a project, and please remember that it doesn't have to be about Nix or NixOS itself. It has to be about search and discovery or about privacy enhancing technologies. Anything goes. So the thing is that if you have got a cool idea, even if it's outside of NixOS, and you think like, okay, well, you know, this is something that that would benefit the world and it's about search and discovery or privacy enhancing technology, send in a proposal, please. So I think the next deadline is December 1st? So December 1st. So you still have about 1.5 months. Packaging software is also something that you could do. There might be a few opportunities for this in the near future. We're just still looking into this. Or you could help improve infrastructure. There might also be a few opportunities there as well. So you should just come talk to us if you're interested. And then how you should send in a proposal. First of all, keep it concise. So you don't need to send in a PhD thesis. A few things like a few pages, clear deadlines, clear milestones, and how much per milestone. That is basically what is needed. And be realistic. Don't ask for the moon, because 11.2 million euros is a lot of money, but it has to be spread across many projects. So just keep it, just be realistic. Split big projects into several smaller parts if you would want to, and be patient. So the proposals are first reviewed by an independent committee, and then they're sent off to the EU for additional review. So you have to think of, so one of the reviews that the EU will do is something like looking at if you're not on a blacklist, because they actually have a blacklist where people who applied for grants but were convicted for fraud or whatever, they will simply not be able to participate. So this process takes some time. It could take some months before you get the go-ahead. So if you're thinking like, okay, well, you know, I need to be starting on December 2nd, then, well, no. Then you have to calculate that there will be a few months delay in there. It's just how it works. Also, get inspiration from existing projects. All of the projects that NLnet has funded, they are on their website. And the thing is that is very important. Even if you're not in the EU, you can still send in a proposal. So what is important is that it benefits internet users in the EU. It has to be for a better European internet. But the thing is that something that's good for the world is probably also good for Europe. So even if you're outside of Europe, you can still send in. So I could make an obligatory Brexit joke here. I will not do that, but even if you're in the UK, you can still send it. So some of the approved projects right now. So Nix packages update from Ryan. That is one that was approved. So he will be working on things like automatically checking CVEs to see if there are updated. So if there are updates to packages, and then automatically try to integrate it. Spectrum from Alyssa. So she's working on that as well. So that also got some funding. And of course, you just saw Samuel's talk about mobile NixOS. But of course, that's not the only stuff. So some examples of some other projects. One that I am personally very excited about is Be Trusted from Andrew Wong, who's some of you might know as Bunny. So he's making a protected hardware device for protected matters. That's so something like some sort of sleeve for your mobile phone where you can store passwords, and then your phone actually has to access that device to get access to private things. So all those evil apps cannot get access to your private data. And that's something that personally I think is super, super cool. Another one that I have not looked at, but which Jos said is super cool, is VerifPal, which is about verifying security of cryptographic protocols. Maybe you want to talk about that for a few seconds?
Yeah, okay. Hello. So my name is Jos van Hoeven. I actually work for Nelnet. So if you have any questions afterwards about this process, just come to me. I'm here until Sunday. So happy to talk to anything about anything. But this VerifPal project, yeah. So cryptographic protocols, of course, it's very important. We are financing this project under the guise of privacy, because if something is not safe, you cannot protect your privacy. And what VerifPal is it's a simpler way than of verifying protocols than what academics are using right now. It's very hard to prove that a protocol is secure. And what the author of VerifPal has done, he has created a infrastructure, a software project that makes it much easier to verify this. And on top of that, he even used our financing to hire a manga company to write a manual, which is completely in manga style. So if you look up VerifPal project, you can have some nice manga reading and learn something about security.
So I'm not sure what kind of comic book style we should use for NixOS. So, and then also another project, Discourse Activity Pub. So you can have a distributed thing with likes according to Jos. But that's of course not the only way you can actually get funding. So there are many, many other opportunities to get open source development funding, including things like tax cuts and grants. And a lot of people that I talk to, they actually don't know that these opportunities exist. So I just want to highlight a few of them. So in the Netherlands, companies can actually get an income tax cut for innovative work. So it's called WBSO. I will not say it in Dutch because most of you would not even understand it. But basically, if you're a freelancer or a sole trader or one-person company, whatever you want to call it, or you're a limited company, you can basically apply for this and have a tax offset for your income tax, which is very, very useful. So I actually use that for my own company. I spend a minimum of 500 years on research and development, and then I get a tax reduction. So my taxable income is actually lowered with the subsidy, and over that part I basically don't pay any income tax, which easily saves me a few thousand euro per year, which is nice. This is actually quite common for companies to do in the Netherlands. There's a whole industry built around these subsidies. So sometimes it might feel like it's unethical, but I'm just thinking about I'm taking back my tax money to do good stuff with it instead of some companies that was just built around getting subsidies and then just lining their own pockets, which is very often what happens. So this is a good thing. So then there's also starting companies that can get an even higher tax cut. So if you're thinking like, okay, I have a Dutch company, I want to free up some of my personnel's time to actually work on open source software. You have a research proposal, you send it in, at least you get a tax cut, and you can deliver something to the world, which is beneficial to a lot of people, which is nice. So if you're kind of evil and you're doing things like patents or selling licenses to IP, then in certain, so also in the Netherlands you can get a very big tax cut on some taxes. So instead of 25%, you only pay 7%. So that's what the big companies are using by selling their IP. So of course I'm hoping that none of you are actually thinking about applying for patents and then licensing them to other people. But that's another discussion we can have. But I'm using this to illustrate that there's a lot of stuff out there that can be used by companies and that actually is being used by companies. And most open source people don't know anything about it, and that's a wasted opportunity. So in Sweden, there is also an innovation agency that you can also talk to about research grants called Innova. So I know a few people who've done that successfully, and they're also using it to do open source stuff. It's very useful. In the Netherlands, there's the ISDN fund. So that's the domain registry that has their own fund to work on programs to improve the internet. So you can also apply for something between 10,000 and 75,000 euro for a grant if you're doing something good for the internet. So in Germany, you can go to the KMU Innovativ, which is something from one of the federal ministries. So you can actually apply there as well. They have a research and development program. And there's things like the Prototype Fund. These are all open to research and development or open innovation. So in your country, there are most likely opportunities as well. So I haven't even looked at things like Spain, but I'm pretty sure there's something like that there as well. In Italy, there should be. In France as well. But it really pays off to do some research into this if you would just want to have someone to pay you for doing open source software development with or open source research. So if you're in this situation, you're thinking like, okay, well, I really want to work on open source stuff, but I don't know where to get the money from. Just look into this. It can really pay off. And then basically, Q&A. Anyone?
So I work for Mayflower, a medium-sized company, and I'm wondering if I have a project where I want to improve Nix, would it make more sense to try and do that through the company or independently?
I would say that depends on your contract with your company. So, I would first talk to your boss about that, because it might be that your contract actually says that everything you do, even in your spare time, belongs to the company.
That's not the case.
If that's not the case, depends on whether or not you would be competing with your company. So what I would do is just first talk to your company, talk to your boss, and work something out. And even then, it might be better if the company actually applies for funding.
Yeah, so there's, but is there anything on the side of, well, NLnet that would speak for one or the other?
So from the side of an LNet, we accommodate both. So if you want to apply as an individual, that's fine. And in some countries, it's good to get easier to get tax cuts because, as was said, if you get a grant from us, basically what happens if you send in a plan, you fulfill what's done in the plan, and then we give you a donation. That's not taxable income, right? So that's an advantage to you. If, however, you do it with a company, then the company will have to pay taxes on your salary. So depending on that, you can make the evaluation what would be more beneficial. Obviously, you can do it via the company if that's something they would prefer. But you can do it as an individual, as a company, as a combination of a company, individual, non-for-profit. From our side, anything goes. We just, when you put in a proposal, we accept it. We write a small memorandum of understanding in which we say, when you do this, we give you a donation. And that's who is part of this MOU doesn't really matter to us. In this case, there has to be a link to the EU, but that's it.
Other questions?
Yes, can you say anything about the like who reads these? How technical can you get in a proposal? Do you need to dress up certain things or?
Well, so Jos is actually reading those proposals, so I'm just going to give the microphone back to him again.
Okay.
Well, our employees are, so it can be fairly technical. I mean, I'm a NixOS user. We have, more than half of our people are using NixOS. And of that, more than half would be able to write a NixOS recipe themselves, a NixOS expression themselves. So fairly good. That doesn't mean that we know everything about all of the cryptography layers, but we do have a long history of subsidizing projects. So we mainly know not just the technical stuff, but also who are the long-time players already. And we know how to look at, for example, commit histories in projects, if that's something you want to reference. That's something that we can easily understand, even if we don't know the particular library you're talking about. We can very easily look at your commit history somewhere and see, look, this guy wants a grant for this project, and he helped start it. Or since half a year he's the maintainer, or he's written this cool feature for it. That's something that we do look heavily at.
I don't have so much as a question as like an addition to that. I applied with Lizard, a project to do open communication stuff. The proposals you get to send in are fairly limited in terms of words, so the amount of technical stuff you can actually squeeze in is fairly limited. Like, if you want to go into details, you straight up don't have the space for that. So that makes things a bit easier.
Hi, thanks for a great talk. I'm curious about what's your view on collaborations? Say two individuals or two companies would like to make a proposal together. Is that something that you've done before, or how's the process around that?
We do that all the time, yeah. But what we do often prefer, if a collaboration is fine, if you can split it up so that you have independent projects that have independent deliverables, that's something we always prefer, because it makes it easier that if one part of the possible collaboration finishes early, we can already finish off that administratively. Whereas if you're in a collaboration, you depend on that everybody finishes to get to wrap up the project. But yeah, of course, we very much encourage collaborations, and we also encourage that when you apply, you look at the proposals we funded in the past, because then you have an idea of the sort of the type of projects that we do. it actually goes from very low in the stack to very high. That's something, the bandwidth, which wasn't yet very much emphasized, but we have supported hardware, actually routing hardware, but we also support end user applications, right? So it can be very wide.
Thank you.
I have a question. So this hasn't been addressed. So I'm curious, like with regards of the funding itself. Okay, you can get tax cuts. That's great. But what's a reasonable expectation for the funds? Like, can you get like industry standard rates, or is it like how does that evaluate in the proposal? How do you explain the
So of course, if you're a highly paid consultant asking something like 200 euro per hour, forget it. That's not. I don't think that the EU will actually say that that's okay. So no, industry standard rates, that's not going to fly. But I think that what would be a reasonable ballpark figure?
As you saw in the presentation, currently we have allocated 4 million for 120 projects.
Yeah, I mean, okay, that still depends on how many people and for how long. So yeah.
Most of the projects are single individuals. But yeah, if you would like to go with an hourly rate, then it's the hourly rate is not consultant level. It also depends where you're living. Basically, you are in your proposal. You determine what your hourly rate will be. We just give a donation if we think it's worthwhile.
All right.
So make an educated guess.
All right. Thanks.
But I can give you a few hints after this talk.
Sorry, just wanted to hook into the same thing, maybe to just simplify the question a little bit. I guess the main question is it something where you can say, I want to have a project on which I want to work full-time for a year, for example, of which you can like pay living costs, for example, right? Is that the kind of target? Or would it be something where you say, no, usually when people want to do a long-term project like a year, it would have to be a side project next to your normal work, for example. I think that is the kind of thing that is the most interesting thing about that.
So I think there's actually both. That some people are doing it as a side project for just a few thousand, and I think that some people are there asking for a bigger grant. So I think that the maximum you can ask is
for a really good first-time proposal, we have given out like 50,000. So that should cover your expenses for a long time. But we've also there was one proposal, for example. He was a really great project to extend an existing project with ActivityPub support. And ActivityPub is a standard to sort of build a decentralized social network where everybody just likes each other via messages on their own website. And I'm not sure if it was the one that was extending discourse, but it was a great project which we liked. So we wanted to fund it, and at that point, the guy who was going to do it got accepted into the solid team of Tim Berners-Lee. And obviously he went for that, but he said, I still want to do that. Can I do it in the weekends and then ask for, well, much less, obviously. And we were so happy that he was still committed to doing the stuff that he wanted to do before, that we accepted it. So you can do it both. You can combine something which you want to do in your spare time, or maybe reduce your number of hours a week a bit, and in that time work for an LNet project, or try to do it full-time.
So I think there are no more questions because the microphone has been taken away. So if there are any other questions that you just want to ask us, so both Jos and I will be here for at least today and tomorrow, and Jos will also be here on Sunday. I will not be. So just come up to us, ask questions. We would be more than happy to answer them. All right, thank you.
Let's take a 10-minute break.
Hey, welcome. I'm Florian. And I need to press elsewhere. There we go. Hi, I'm Florian. The internet knows me as Flokli. Apart from doing Nix packaging all day, I'm interested in build pipelines, infrastructure, low-level user space stuff, networking, and tinkering with hardware in general. At work, I work as a site reliability engineer at Tweak. By the way, they are hiring, so if you're interested in that, just reach out. Today I'm going to talk about Untrusted CI and how to use post-build hooks to get automatic caching of untrusted builds. I'll be talking about CI in general, what you want a CI to do and how you want it to behave, about Nix binary caches in general, how to use private caches and how to handle signature of those builds in the private caches, how to handle limitations in simple implementations, proposed solution, how this improves things in general, and future ideas on what to do with it. So how do we want the CI to behave? Well, it should, in general, it should lint, it should analyze, it should build, it should test and package your project. It should do that on each commit to assist developers in their workflow while they are iterating over a PR. So especially you want it to run on PRs to discover all breakages before they reach master, or most of the breakages before they reach master. But most importantly, you want your CI to be fast. So if you're waiting for like 30 minutes or an hour to get your tests to pass or not to pass, and you basically blocked on spending your time on this, yeah, that's just a huge problem and massively decreases developer productivity. So yeah, with a small project, that's not so much a problem, but as projects grow, and yeah, build time likely does as well. So still having a snappy CI becomes more and more challenging. And yeah, when using Nix to provide those dependencies, or like build the entire project, you can make use of binary caches. In fact, we do already most of the time. There's cache NixOS.org for all the packages and Nix packages built by Hydra, except unfree and packages currently failing, but that's another story. However, in your project, there might also be other packages not generically suitable for Nix packages because they are domain-specific stuff, they are custom overrides or non-free packages, and you still want to cache those in your CI pipeline. So what you then do most of the time is you might have an Hydra or whatever does your build, but in general you go with a private cache of some sort that is added on your developer machines, and they can make use of this cache of some sorts. It's either self-hosted or based on some bucket in some cloud or entirely managed. So I'm going to be talking about how to set up those caches quickly. What you do is you generate a signing key pair on one machine. On all machines that use this cache, you configure your NixOS configuration or your NixConf to point to those endpoints, to the public endpoints to download the binaries from, and you add the public key part of the signing key pair. And to upload, you use some sort of Nix copy command eventually, or you expose your entire Nix store of some machine to the others. And in general, Nix copy supports like SSHNG to copy to another machine, HTTPS, like a HTTP put to upload stuff, S3 buckets, and there's a in-progress PR to push to GCX buckets as well. Yeah, so assuming your project has a default Nix and a dependency attribute containing all the dependencies of your project, you might end up with doing something like this. Oh, I should probably not move the mouse. Yeah, you somehow get a list of all the dependencies and all the Nix store paths that are part of your build your dependencies of your build or of your entire project, and then you issue a Nix copy command if you don't expose the Nix store. Yeah, so what are the limitations of this naive approach? It might work in a lot of cases, but sometimes there's some drawbacks. Like you might not have all the build dependencies readily available at a central location. So you can't call nix build -a and some magic attribute because there's scripts invoking Nix by themselves. You have some shell scripts calling Nix shell, or you have Bazel shelling out to Nix build to build other packages. So you have IFD and don't really know at first what you're gonna end up building with. Yeah, and of course you can track those manually in your .nix file and make sure that you cache everything, that you basically catch all the packages you want to build and make sure you say I built it and then you start the actual build process. But that's all like quite laborious and it gets even harder. Yeah, it doesn't get better. Another problem is that if one of those packages fails to build, the approach of waiting for the output path and then copying over the whole transitive closure will just won't kick in. Because it never got a chance to upload these intermediate dependencies if you have not specified them before. So yeah, you might end up bumping a higher level thing, it fails to build, and all those other dependencies you also need to rebuild for some reason, they just don't end up in the cache because you never reach to the endpoint of actually building the package, like the leaf package in your dependency. Another problem is that the upload is another manual step in your CI pipeline. Very likely you end up with code dealing with all the signing and uploading part inside your CI code itself that should in theory only say like, I'd like to build this thing, and then it should be cached. You don't really want to mess with looking what you want to upload and then manual calling to upload it. It just normally it should just work and it shouldn't increase your pipeline code. And another problem, which I personally find a bit of a bigger problem, like as the binary cache is added and used as a substitute on all developer machines or probably even production machines, having write access to it and having developers or like external contributors being able to change this way of your scripting inside your CI pipeline, it's very easy to extract the signing key, and you basically don't want to have a backdoor and want to have somehow a way to pollute the cache in some sorts. Yeah, so yeah, that's all not so nice. And while 1 and 2 might just decrease cache hit misses, and 3 might be just annoying, like 3 and 4 together, due to the reasons mentioned, basically require some sort of approval process for PRs, at least for external PRs. Yes, and that's all not very nice and negatively impacting both cache hit rate and thus round trip time for developers. So how do we solve this? There's one way to solve it that I'm going to propose. It's together with multi-user Nix and some recently introduced Nix feature, you can basically fix this. Yeah. You basically, what you do is you have a CI user that runs your regular build process. It uploads a build recipe to a privileged Nix daemon. Oh, those animations work, nice. And this Nix daemon, yeah, is basically instructing all the builds to happen on some temporary, unprivileged other sandboxed build users. And afterwards, it takes care of persisting it to the local Nix store. And assuming you have no local user privilege escalation on that machine or some weird hash collisions, this effectively prevents regular CI users from manipulating the local Nix store. Like in a non-multi-user Nix installation, basically all those 3 different concerns would be running as the same user. So the regular CI user could, in practice, like modify the Nix store in some weird ways, in some cases. So, yeah. Multi-user Nix in that case solves a lot of those concerns and isolates this. it's a default on NixOS, but it's not the default on a lot of the hosted CIs. Like if you have Travis or Jenkins and you have your Docker-based CI, and basically there's like a shell script that you call to install Nix, and then you end up with a single user Nix installation. Yeah, I will. No. It's one way to configure Nix in a certain case, and yeah. Okay. So with that, we kind of solved the direct access to the Nix store, but we did not yet solve the signing part. So if we go with the bash loop approach we saw previously, we still end up signing inside the context of the CI user. So the CI user can still like change stuff before uploading to the remote cache. And that's something we don't want to do, because this way the user can still extract the signing key, and if he has some way to access the S3 bucket or something, he could modify stuff, resign, and basically get code execution on other machines. So yeah, we don't want to do this. As I said, with Nix 2.3, there's a way around. You can configure a post-build hook, which basically gets triggered for each realized derivation, even the intermediate ones. And in multi-user Nix, it's run as in the context of the Nix daemon. So as a privileged user, and you don't have the problem with exposing the key to the CI user. And instead, it's run as maybe as the root user. Yeah. There's some side notes regarding this. Like normally, you don't want to exec Nix copy there because it's blocking. You want to queue the upload to happen to some other process, so you don't block the main build process. So let's look back at our limitations that I spoke about. The CI user doesn't have any direct access to the local Nix store anymore, and doesn't have access to the signing key. So there's no way to produce a modified signed artifact under the original store path, which effectively fixes number 4. As I said, like in some cloud environments, users might still be able to alter files in the cache because it's just like a cloud setting that this machine is allowed to access this bucket. But as it cannot access the signatures, substitution won't happen because Nix will verify the signature. It will realize, hey, it's the wrong signature. It won't substitute from there, and it might fall back to build locally. Yeah. By moving by moving the uploading logic away from the CI pipeline into the generic post-build hook in a multi-user Nix configuration, we also fixed 3, because we don't need to have any manual scripts inside our CI process. And because the post-build hook is triggered on each derivation realized in Nix store, no matter how we end up building this, we also solve 2 and 1. Yes, so we don't need to manually maintain another list of dependencies. We just catch all intermediate builds. So, as I said, like above architecture will automatically upload all builds happening on a certain machine into the binary cache, and can be entirely described in this CI build slave image that you run on your cloud provider maybe, without the need for any cache-related configuration in the build pipeline itself. That means it's currently most suitable when you provide your own self-hosted builders, because multi-user Nix requires multiple users, and setting those up outside the repo and not inside of some of those, setting those up outside the repo most of the time means like you can't use a lot of the hosted CI solutions that like have used some sort of shared runners, because there's just no way to set up other users there. It's just often not possible. But depending on your thread model, you could still start using post-build hooks in a single user Nix setting, which will at least solve limitation 1, 2, and 3. Yeah, that's what I already spoke about. Yeah, another problem is that running Nix inside Docker requires privileged containers because of some of the sandboxing features not currently working and failing, so it might be unsuitable for some container platforms. Another problem is that the official NixOS Nix Docker image doesn't provide a multi-user installation, but it's based on Alpine and a shell script installing Nix. Yeah, but as I said, depending on the platform you're running on, you could go with multi-user Docker containers, privileged ones as well. Yeah. So TLDR, use post build hooks to upload to the cache instead of other hacks. Future plans. So when new machines are spinned up in off-borg, they often hit another node in the next off-borg run, and you have to wait again for dependencies to be compiled. So one way to fix this might be to have off-borg use not the official cache NixOS org bucket, but another bucket that all the builders share. And we could still not worry about having to pay too much money for it because we could just nuke it. Nobody's really relying on it, and we can rebuild it. So either by garbage collecting or throwing it away completely in like some weeks, for all some weeks. What I'd also like to see is nicer tooling in general and documentation on how to use it. A daemon to handle the asynchronous uploads. There's a Nix copy PR to upload to support GCS. That would also help in some cloud environments, but it's not strictly related to post-build. Yeah, and as I said, more documentation in general and how to integrate this with CIs. So maybe some NixOS module describing on how to wire this all together for your own self-hosted machines. Have some code ready that I would like to open source. But it's really not so much, not so much code. And also maybe a GitHub action template. I mean, with GitHub Actions, as far as I know, you cannot have multiple users, but you could at least get like the single user part set up with post-build hooks. Yeah, and some blog posts describing this in a more readable fashion than a slide. That's from my side. Thanks. Any questions?
Have you looked into implementing a post-build hook script that can upload the source tarballs and the patch files that were used to do the build to a content address tarball cache?
No, but it's an interesting experimentation field.
When the build hook fails, of the post build hook fails, does your build fail?
I don't know, to be honest.
Okay. And logs of the build hook, will they kind of say if I run this from Hydra, where are the logs of this hook go to? Will they end up in the log of the build, or are they?
I think it's the Nix daemon logging it. Can you get a mic? I get my mic. Or like this.
Yeah. The hook's output always goes to the user's terminal. If the hook fails, the build succeeds, but no further builds execute. And the hook executes synchronously and blocks other builds from progressing while it runs.
Okay.
You mentioned possibly doing garbage collection of the S3 buckets. Does such a function actually exist with Nix collect garbage, or a tool to garbage collect the buckets?
I think there's a Perl script which is a bit old, but I don't think we're actually running it on cache NixOS org, and we could dogfood this script on the off-borg bucket. All right. So if there's any more questions, feel free to hit me after the talk. Thanks.
Thank you, Florian. And if I'm not mistaken, now we have a hour and a half break for socializing, perhaps getting something to eat.
Hey everyone, my name is John Latosky, and this is my boss actually from IOHK, Samuel Leathers, and we're going to talk today about a NixOps plugin architecture, and Sam is just going to give an introduction to what we're about to talk about today.
So I want to tell you guys a little bit of a story here. This story goes all the way back to 2016 of December, when someone opened this issue to support Vultr and NixOps, and this is still not addressed yet at this point. So fast forward to May of 2017, and I actually implemented it. I got it working, everything works, I still use it today. It wasn't implemented the best, it doesn't have tests, the documentation was pretty shoddy, but it works, and once it worked I was like, okay, it works for me, good enough, I'm not going to push to try to get it in. But I've been rebasing this on master and dealing with merge conflicts for a few years now, keeping my system up, and I think one other person might be using this fork of NixOps that I have as well that has commented on it in IRC before. So it's not heavily utilized, but it's really a pain managing this. Fast forward to last year, IOHK decided we wanted to add packet.net support to NixOps, which was great, except for we did the same thing. We forked NixOps, we started working on it, we never quite got it to stable where we wanted, and we've been dealing with lots of merge conflicts since we wrote that little piece of code. And it was painful, and then Graham Christensen approached me and was basically like, hey, I got this PR I opened on NixOps plugin architecture. Is this something you're interested in? I'm like, I think IOHK can definitely help out with this. So I did what every good manager does, and I hired someone and told that person, your first task is to figure out how to do this. So here he is.
Thank you. Okay, so we'll just go through some of the basics here to start with. So for those of you who don't know, NixOps is a tool for deploying sets of NixOS Linux machines, either to real hardware or virtual machines. And it extends NixOS's declarative approach to system configuration management to networks and adds provisioning. And as Sam just mentioned, we're using it quite extensively at IOHK. So from straight out of the NixOps user guide, if we just take a look at that, we can see that NixOps does support a number of infrastructure provider resources and other resource types throughout the lifetime of NixOps, and some of them are like cloud providers, AWS, GCE, Azure, Hetzner, virtualized infrastructure such as VirtualBox, libvirt, QEMU, and metrics resources such as Datadog. And providing functionality and support for each of the numerous resource types above has led to a fairly large monolithic GitHub repository. So if we look historically at some of the stats, we see that in about 2016, it looks like the lines added and the commit count started trending down a little bit. And similarly, we can see that with the lines diff and lines deleted as well. And some of the thoughts in the community as of roughly mid-2018 could be summarized as a majority of those at the time, around mid-2018, were for PRs, or of the PRs were for providers. And PRs to NixOps were very slow to merge because, well, it's super important that they work, are stable, and don't break anything else because users depend on it. And for a lot of the providers, people don't really know how they work or interact with other stuff. And it's hard to know how to add a new provider because everything is so tangled together. So it's really hard to add a new provider because it has to be in core, and Sam's earlier introduction kind of speaks to that. So as a demo, we'll just look at what a very simple deployment is going to the monolithic version of NixOps from the past. And this is pre-recorded, so we don't have any unforeseen delays. But basically, we'll install this imperatively, and we'll install NixOps 1.7 just with NixEnv. I can make it larger. It probably wrap a lot of lines. Is that better? So we can look at the deployment file, and you can split up your deployment files into a logical file and a physical file. Here, because this is very simple, it's just both the logical aspect, which is the software we're deploying is just Nginx with an index.html that's custom, and then the physical deployment type of VirtualBox, it's just in one file. And then we create a deployment with that, and the VirtualBox plugin doesn't yet have an image in 1909, so we're going to fix the channel to 1903. We create the deployment, give it a name. Now we check for deployments again, and we see that a deployment is there. It doesn't yet have a description, and the machines show 0. But now that it's there, we can deploy the deployment, and NixOps will build the machine locally, then it will copy the path. And it brings the virtual machine up, attaches the disk, waits for networking to come online. And this doesn't take too long. So it gets a network IP and starts copying the closure over to the machine. And this will take probably 20 or 30 seconds. So while we're waiting, could I see a show of hands for those who have not used NixOps or are not familiar with NixOps? Okay, so good number of people. Okay. And it's just about done. So it's copying the rest of the closure over. In a moment, it will restart services on the target virtual machine that is running on localhost. And now the deployment is finished, and we can get information about the deployment. And now we see that there is one machine. It has an IP. There's also a network description, NixOps 1.7 monolithic demo. And to verify that the machine is up, we can curl Nginx at the IP and see the hello NixCon 2019. So that's kind of how the monolithic version of NixOps was functioning. So given that we saw the commits going down and the feeling was, there was kind of some blockage in being able to make commits to NixOps, a migration to plugin architecture was considered, and it was considered that it may solve these issues. Of course, it might add some additional complexities that would need to be addressed, but it also had potential to open up functionality further in NixOps, such as adding other language support via plugin RPC. And Graham did the initial proof of concept branch back in mid-2018, and he demonstrated basically a NixOps core repo with just about everything stripped out of it as far as the functionality for providers go, and then a separate standalone AWS plugin repo. And Graham's initial proof of concept utilized Pluggy, which is a popular, flexible, extensible Python plugin system, to bring NixOps core and the plugin repos together. Pluggy was kind of the perfect thing, and as it says right here, which is straight out of the Pluggy read the docs, it gives users the ability to extend or modify the behavior of a host program by installing a plugin for that program. The plugin will run as a part of a normal program execution, changing or enhancing certain aspects of it. So this kind of seemed like the perfect fit, and we just continued forward with using Pluggy. Just from a very high level, some of the common elements in each plugin repo that would be created as it's split out from NixOps core. There is, in its own plugin repo, a file setup.py, and that describes the initial plugin entry points, and the packages are defined there. There's also a NixOps plugin directory, so it would be like NixOps VBox or NixOps AWS with a pluggy.py file, and that defines the API hooks of Pluggy essentially, and as of right now we're utilizing just 3 hooks, and that's a load hook, which will return a list of the plugin Python modules from the plugin to get loaded into NixOps core. Nix expressions hook, which will tell core what Nix expressions need to be loaded in to be functional, and a parser, which is used to pass the argparse functionality of Python over to the plugins so that the command line can be extended out into the plugins. And this might be a little hard to see, but we'll look at it again. It's just included as an example. And this is the plugin.py file for the NixOps packet plugin repo. And it just shows we have our 3 hooks in this one file. The Nix expressions hook, the plugins hook, which shows we want to load 4 modules in, and then a parser hook implementation so we can extend the NixOps packet out with a CLI hook. So the initial approach taken for packaging and updating plugins with NixOps core was to be similar to what we see with the Terraform providers approach in Nix packages. And Terraform providers utilizes 3 files, data.nix, providers.nix, and an update all script. And essentially the data.nix is just, it's an attribute set that forms fetch from GitHub attributes. And the providers contains a list of repos and the GitHub user for those repos, and the update all script just gets run and it can update then that attribute set that's in data.nix. So for the main PR that converted the NixOps core repo from monolithic to plugin, that was PR 1179, and a follow-on PR 1198 implemented this approach. And it's almost identical. It's just a little bit different with the file names, and the bash script got cleaned up a little bit to be a little bit more flexible. So this will be a demo of the new approach, and we'll show how to basically do a deployment with VirtualBox like we just did, except with the plugins. And we'll give an example of how we use that update all script and do a local build to get NixOps with those plugins. So first we'll uninstall the NixOps we installed before imperatively. And this plugin version of NixOps is not yet incorporated into the unstable channel. So we'll have to pull it from Hydra as a master tarball, or we can just git clone the repository right now. So we'll do the latter, just git clone. CD into the directory. We'll fetch the PR, which really all this extra PR does that is currently unmerged is just add some extra documentation, and it cleans up the script so we don't have to have a GitHub API token here right now. So now from the source that exists in this GitHub repo, we can immediately build the NixOps plugins that are already in the data.nix file. And these are the AWS and Hetzner plugins, and we can see their fetch from GitHub attributes right here. So to build with one or both of these plugins, we could just look at the README. And there's a few different ways we can build it in roughly the middle of the screen. We can do a fairly typical Nix build, and there's an extra argument that takes a parameter p, and we can specify what the plugin is. Alternatively, we can do a dev shell build, which essentially builds the software and drops us into a Nix shell. And we can just specify on the command line what we want. And if we want to iterate quickly then by having another local plugin package and exit the shell and re-enter with a new build, we can do that pretty quickly that way. So we'll just do a build with the AWS plugin in a dev shell. And there's the command at the bottom. And typically there's quite a bit more output, maybe 5 pages, and it takes 10 seconds or so. I've pre-built this previously, so we don't have a whole lot of output here. But now, NixOps shows a new command. At the bottom, there is a list plugins command, which is not in the monolithic NixOps version. And if we list plugins, we can see that the AWS plugin is installed. Or we can look at a more verbose option, which shows where that plugin is stored in the Nix store. So we could now deploy an AWS instance But what about the VBox plugin that we installed before? So if we'd like to do that, how do we do that? Because it's not in the data.nix file. So we could certainly populate it manually, but more preferably, we'd like to use what's already here, which is the all plugins.txt file and the update all scripts. So if we look at the update or the all plugins, we see that there's just 2 entries, which is for the AWS and the Hetzner, and we already have those plugins. So we can add the VirtualBox plugin to this, to the all plugins.txt file, just using the GitHub user and repo format. So we'll add that line to that file. It's there now. And then we'll run the update all script. And what it does is it reaches out to each of the repos and looks for the latest release tag, and then generates the fetch from GitHub attributes for that and sticks it in a new data.nix file. So that's complete, and if we take a look at the data.nix file, it's now updated at the bottom with the VBox fetch from GitHub attribute. So similar to before, we can now build this with both the AWS and VBox plugins. We'll exit the dev shell and then reissue the similar command, this time just with the extra VBox plugin. And if we list plugins, we now see we have VBox support. So now we can do a quick deploy. It's the same steps as before. So we just create the deployment, and I believe this won't take as long. And since it's pretty much exactly the same as what we saw the first time, we probably don't need to sit through and wait and see the end here. But it's going to deploy exactly the same way. The only real difference is that this repository is now built using plugins rather than the monolithic repo. So I will just well, let's see, it's almost done. So now that it's deployed, similar to before, we'll get information about the repo. We see it's at a different IP address, and we'll just curl it, make sure it's operational. And now we see, yes, it says, hello, NixCon 2019 from a plugin deploy. So some drawbacks to this update all method, well, it's a mix of manual intervention with bash and nix, so it's not really that ideal. Also, it just pulls from the latest tag commit in those repos to build that data.nix file. So if you want to do something like build from a specific branch or a specific commit, you know, it's not that flexible. So there's another approach that we've taken that we're using at IOHK, and that's to use a dependency manager. And just one example is niv, using niv to pin different sources. So this may also be a little bit difficult to see at the back. I can expand it in a few minutes in the command console. But essentially, we have a default.nix file, which we can specify an overlay for Nix packages, and we're going to make NixOps one of the overlay packages in there. And we specify the P parameter, just like we did on the command line. But here we can specify plugin sources such as NixOps packet, and we can declare this to be any commit or any branch in that repo. We can also have a local GitHub repo that's not checked in anywhere, but it's just local, and hack on that and specify that to be built from a local source. And additionally, anything that is in data.nix originally that we could just build from the command line like that, we can still put it in as the P parameter down here in the list. So this is a little more flexible of an approach. Additionally, this next demo will show taking that approach and using niv, but we'll also show how you can extend the command line. For instance, using packets SOS console, which is serial over SSH, so you have out-of-band management for your servers if your network goes down or you need that for some other reason. And I'll try to make this a little bigger. Oops. And one of the other things we're doing in this demo here is we're using direnv. So when we enter into the deployment directory, we can automatically have NixOps built through a Nix shell, because NixOps is one of the dependencies of that Nix shell, as well as NIV itself. And in this directory, we have default.nix. We have a Nix directory that has the NIV sources that are pinned, and we'll look at those in a second. We have a packet plugin.nix, which is the deployment file that specifies the server to build. A shell.nix that pulls in the NIV dependency and the NixOps dependency. And then also the local NixOps vbox in case we wanted to pull that in as well. In the Nix directory, we have the NIV pins, sources.json and sources.nix, the default.nix, and there's an unrelated file in here, packages.nix. So for the packet deployment, this is really only a physical spec. There's nothing in here that's doing any logical deployment of software or anything else. This has already been spun up prior to this demo, and the reason is basically you just want to show that the machine is up and show some new command line features that are part of NixOps using that command line enhancement hook. So to see what the NIV source pins are currently set to, we can look at the Nix sources file. And it's a little off the screen because my font is big here, but you can see we're pinning the NixOps repo to a specific branch at a specific revision, and also doing that for Nix packages. NIV is up above, and also NixOps core, we're using a fork actually pinned to a specific branch and commit as well. And as we saw in the slide that was smaller than this earlier, the NixOps is defined as an overlay using those different types of sources, one being the NIV source, another being a local source, and the final one being the data.nix source. So now we'll enable direnv so that we can just, it'll drop us into a NixOps shell with NixOps in the path. And we can list the plugins. And we see that we have the AWS packet and vbox plugin that we had wanted and defined in the default.nix. And if we list deployments, we see there is one machine there that's a packet machine and was pre-deployed prior to this demo being recorded. And there's a packet machine with the packet key pair that's needed to SSH into it. And now, if we just tail the NixOps help, we do see that there is a new command in the NixOps command structure, and that's the packet command to run packet-specific plugin commands. So we get a little more help on that. We see it has some structure. We got to do NixOps packet SOS console to connect to a machine's SOS console, and takes a few additional parameters like the deployment and the machine name. So we'll just try it out. This is the demo 3 deployment on packet 1. And you can see we have a login prompt, and this is connected with out-of-band management, so even if the networking's down, we can still get access immediately. And you could do this outside of NixOps. You can SSH to a specific URL or a fully qualified domain name, and you'll get access, but this is just much more convenient. You can issue this command simply, and it shows that really any plugins that are made can extend out the capability of NixOps through the command line as well. All right, that's the end of that demo. So just to summarize, the work involved in changing over to a plugin architecture from monolithic was Graham's initial POC around mid-2018. The big PR that did the migration was in September 19. There's another PR that's unmerged that just does some script and documentation improvements. And then most recently, Elko has put a PR up that's unmerged. It's really just a few days old, I think, that moves to Flakes. So that looks to me probably the way we'll be going in the future is bring all these plugins together with Flakes. So here's a little merge drama. When that plugin architecture PR merged, there was a whole lot of lines deleted. It's a little exaggerated here because it's double counting the lines actually. It's really just 32,000 lines we deleted from the core. And so the actual plugins that are out there right now, you can see them on the screen. There's quite a few of them. Some of them are hosted on by the NixOS org. Some of them are hosted at Nix Community. And there's a few third-party hosted repos as well. And I actually forgot to put my boss's Vulture repo on there that he just mentioned earlier, so sorry about that. And the future is probably, as I mentioned, with Flakes. I look forward to learning how to use that. And some possibilities that we can do with the plugin structure is to extend NixOps capabilities with RPC, or maybe more generally IPC, to interface with other languages through a plugin or to bridge to other services. And there's still quite a bit to work to do. At a minimum, the testing libraries are not really cleaned up right now. Probably need to migrate the testing libraries to each of the plugins. I think a number of them are still left in the core. And of course, we need more documentation for everything. So thank you to everyone in the community for helping make this happen. The community members who helped with the POC, the merge, and moving a number of these plugins over. Elko, of course, for his contributions and moving it forward with Flakes, and IOHK and my boss for giving time to do this, and all other contributors who are helping out. Questions?
Hi, great talk. Just to be clear, you don't actually have to change anything in your NixOps deployment configurations to use. This doesn't change your Nix files.
No, it does not change your Nix files. So basically, your deployment is going to be exactly the same unless your plugin has new changes in it and whatnot. But that would be the same if it was in core and merged in there. This basically gives plugin providers and people that want to write non-provider related plugins, like one thought we had was like a DNS generic backend that could tie into like AWS Route 53 and Cloudflare DNS, that you could basically offload your DNS to multiple things. If someone wanted to do that, they could start taking advantage of this, put that plugin into their own repo, test it, have some other people play around with it, and then eventually, once there's enough people use it, move it into Nix Community. And if it has massive adoption, like AWS, it becomes adopted in the NixOS org completely, and the NixOS org completely. So we broke it down into 3 layers: the NixOS org, Nix Community, and then other forks. And basically, the NixOS org ones have ultimate support. We're never going to break those. The Nix Community ones might break from version to version. It's dependent on the community members to keep those up to date. And then the ones in forks are not going to be really tested at all by any one maintaining core. Anyone else?
Yeah, here. Yeah, here. Can you see me?
Yep.
Okay. I was wondering if, I think the issues that were on the NixOps repo that related to some of the plugins were not migrated to the respective repos, were they?
No, they have not been migrated. That's kind of a manual process to migrate them. We did migrate the commit history, so we didn't lose any commit history for any changes, but specific issues and PRs and whatnot were not migrated, and it's up to the maintainers of those plugins to move those issues. And if new ones are opened, we're just going to probably leave a note in there, please use this repo instead, and close it right away. A lot of cleanup hasn't been done on the repo. Like you saw, my Vulture one is still in there. That one should really be closed because it doesn't apply anymore. And if anyone wants to, especially if you're not very technical and you want to help contribute to NixOps, we would love people to just go through triage issues and help move that. Maybe that might be a good event for the Hack Day on Sunday. Over there.
Yeah, so I think having the plugins is great, so thanks for that. I think the only drawback as a contributor is that if it's possible that people write against the NixOps code or core code in some separate repositories, as a contributor, I may now be able to break many more people's stuff because I may not know that their plugin exists, right? What is your recommended approach to like communicating plugins? Let's say somebody else makes some plugin and I, as another contributor, want to make sure I don't break their stuff. Before, because everything was in one repo, I could just see, okay, these are the, I don't know, 5 providers we have, so I can manually test those. Is there like one place where all of them should be registered? I can imagine that in Nix packages itself, because the plugins are listed there, that might be one place to look. But for example, plugins currently being in development or what, that may be affected by some change of API or what, where should we best communicate, or where should everybody announce their plugins? Do we have like, is there a place we should put that in?
Well, ideally, if you're using NixOps and you have a community around you using that plugin, it should go in the Nix community rather than in your personal fork, which will get a little bit more support because you'll have more community people testing it, reporting issues with breakages. Second to that, I think a huge important thing we need to do is have a versioning system that basically, when we break APIs of how those plugins integrate with NixOps, because there's still going to be work that needs done on core, like this DNS thing I was talking about. That's going to have a core change to it to be able to support having DNS entries automatically added across a variety of different plugins with different backends. So as things like that are done on core, if they're additive, it doesn't really matter. We don't need to worry about announcing it as a breaking change. But if it's something that changes the way something was done before, either optimizes something that we know is going to break a lot of plugins, it needs to be communicated in some release notes in NixOps, and it really shouldn't go into a stable release until we have some release notes available for those changes.
And the second question that maybe you cannot answer directly, but I just wanted to surely bring up, is one thing that traditionally has been difficult with NixOps is testing it with the actual real providers. For example, if I make a Hetzner PR, like Aslik wants to test it, for example, he needs an actual Hetzner machine to test it. Maybe at some point in the future we can make, perhaps as part of this community repo or what, some way that we provide some infrastructure that things actually get tested at upstream providers. For example, asking them for like a free account or something like this that we can use for a continuous integration. Maybe not a question for you, but like as a community, that would be like really good to have for NixOps in the future.
Well, one of those providers is here at this conference. Packet.net sent someone here, so if that's something you're interested in, I would highly recommend you talk to him. As for other providers, I mean, yeah, we need to have these communications with them. It's going to be hard to get some kind of buy-in from like AWS to do something like this, but the more community-oriented ones, I'm sure, are going to be happy to provide some resources. And Packet.net already provides a number of resources to the Nix community already, so big thank you to them for that.
We have a question by Anders on ISC. Is anybody working on a VMware backend for NixOps currently?
I can't hear the question.
Is anybody working on a VMware backend currently?
I don't know of anyone working on a VMware backend, so as far as I'm aware, no, I don't think so.
I have a question about actually using NixOps. So last I checked, it stores all of its state information about the cluster in a local SQLite database, which is fine if you just have one developer provisioning the cluster. But how do you handle this in an enterprise environment with a shared team?
So we basically, it's really the only way to do it right now. It's not ideal, but we utilize shared deployers where basically multiple people can log into it and they have read-write access to that state. And there's some kind of communication on a back channel basically saying, hey, I'm touching this right now, don't touch it or whatnot.
Do you have any plans, or do you think it would be particularly hard to implement like an S3 backend for the state or various other backends, like a Postgres background?
Yeah, I'm not sure if anyone started working on that. That would definitely be something that IOHK would be very interested in, and if we have some time to find a good pet project to do for Nix next year, maybe that will be something we work on. But I'm not aware of anyone currently working on that. If anyone else is here, please let me know. Okay. Is that everyone? Okay. Thanks all.
Thank you. Thank you.
And now short 5 minutes break. So are you guys ready for the last talk of today? We're going to begin in 30 seconds. So the last talk of today is going to be about Nix-based development environments at Shopify by Berkey Libby.
Okay.
Give him a hand.
Does this work? All right. So I'm aware that I'm standing between many of you and beer, so I'll try to keep this somewhat short and somewhat entertaining. I work at Shopify. We're an e-commerce company, software as a service company. We have about 6,000 employees, and maybe 1,000 to 2,000 of those are developers. So that's I work on developer tools there. So that's a bit about this. So what the company does isn't too important, but what we run on is for context. So our developers use MacBook Pros. We have something like 1,000 of them. Our CI is based on Docker and BuildKite, and our production is mostly Kubernetes and Google Cloud. So what that means is we're really straddling this world of Darwin and Linux. Development happens entirely on Darwin, basically, and then production is all Linux. That works in large part because most of our code is in Ruby, JavaScript, things like this, interpreted languages. Ruby is very dominant, especially in our older, more central code bases. Relatively few of our projects have any sort of compilation step. They all basically run from the source, except for, we, like any company, have a bunch of stuff in various languages, and some have compile steps. But the really critical core applications that hundreds or thousands of people work on are basically interpreted, meaning that we have no build phase in development. So that kind of informs the tools we build because we don't care so much about build systems. But we do have the problem everyone has, where you end up with, as you grow over time and have more projects, they all have their own README with setup instructions, and then you're going through this README and trying not to get annoyed at having to install some particular version of MySQL. So I'm getting to Nix eventually, I'm trying to give you context on what I'm adapting this into. So dev is this tool that manages all of that kind of stuff. It kind of has, I like to think of it as 3 groups of commands. On the left you have locating code bases. The middle is a command that sets up all of the dependencies to run that project, and on the right there's a few kind of standardized keywords that we encourage people to implement. So the first group, see if my screencast works. Yes. So you can clone a project. We use the short name, and it kind of locates it on GitHub. It clones it, automatically changes into that directory. And then we have another dev cd command that fuzzy matches based on all the projects that exist on the system. Nothing really super exciting there, but it's using a shell hook, which lets us change the directory. DevUp is the real meat of it. So I created a toy app here. Just ignore what's happening on the left side of the screen for a second, but basically dev is configured with this dev.yaml file, which is kind of the minimum possible configuration that we could use to specify what actually needs to happen to run this application. And keep in mind, this is setting up everything on macOS to run software, and the thing about developers' macOS machines is they're all broken in a million weird ways that you don't expect, because developers do strange things to their machines, right? So this all has to work on 1,000 machines, and the amount of bullshit that we have to do to make that all happen is truly astounding. But so yeah, basically what we're saying is up is a list of, we call them tasks. In this case, we've got a Ruby task specifying a particular version and a bundler task. The gem file is what bundler uses to specify its dependencies. We just list one. It's called CLI UI, which is a really trivial, or small at least, gem that we maintain. And then over on the left, it goes through some stuff and runs them. So number one is some global stuff that happens in every project, and then we did the tasks that we listed. So kind of critical to this paradigm is met and meet is the API that we use to implement all of these tasks. It's like, if met fails, it runs it, otherwise it skips right away. Let me rephrase that. It runs met, if it's false, it runs meet, and then asserts that met must be true. So when you see gold stars here, it was like, it already ran true and didn't decide to run the actual satisfier. It did run the satisfier for bundle install. And then test, server, console, build. These are just like, it's basically just a mapping to like some command to run. So this is super lightweight, but it gives us a huge amount of consistency across our thousands of projects because we just sort of mandate that developers should put something in whatever of those fields are useful. The main thing with dev is like one command to a runnable project. And of course, this is something that Nix can do too, and so you're probably starting to see where I'm going with this. The reality is that our configurations look a lot like this, where we have like homebrew and then, I don't know, 1 million packages. And like actually just about all of those are only used for building Ruby gems with native extensions, right? So that feels kind of not great, especially because then when you have, you know, hundreds of projects that all have the same gems with native extensions, you're all redundantly specifying the same homebrew packages. And then when like one of those homebrew packages updates, you don't have any ability to like manage that version update. So you like end up in this state where 1,000 developers have 1,000 different versions of like libgda or something, and the gem just, you just have a bad week. So there's two things basically that we do in DevUp. We provision files onto the machine and we start some processes, right? This is basically what a software dependency is one of these things. Like you either have a file someplace or you have some typically socket listening on something. So Nix is great at provisioning files. I learned today that it's actually kind of capable of starting processes on Darwin, but I'm not sure. We'll see. So yeah, like, let's use Nix. It sounds great for repeatability and just my team's sanity to like forklift all of DevUp onto Nix. And so I've been working on that for a while. The rest of this talk is kind of like an explanation of the problems I ran into and the solutions I like kind of came up with before eventually realizing that in most of those cases those are already solved problems and I just hadn't found the solutions. So like there is some neat new stuff at the end, but I actually like learned about some things today where I'm like, wow, I can throw away so much code. So I'm going to talk about the boring one first. I know you don't like, you're not thrilled about the prospect of me talking about authentication, but we're at a company where we unfortunately have to care. So this is kind of tangential, but like just quickly, we use an overlay to distribute a bunch of our private stuff. Dev is distributed literally as a bag of files at /opt/dev. And so we just put an overlay in that repo that distributes with the same mechanism, and we link it from the like nix packages.config thing. It's fine. So the main problem we've had with this is like, you can use HTTP basic auth with like the netrc thing that Nix does, but we kind of like would really like to use OAuth 2 to Google Cloud for a lot of things, and man, that's just painful. So one thing that we want to do is like, we have a private overlay, so of course we want a private binary cache so that you don't have every developer building everything from that overlay. So CacheX is an option for that, but the authentication model didn't work super cleanly for us. And this was an experiment at the time, and it's just insanity to try to get our finance department to fund an experiment. Maybe not, I don't know, I didn't feel like dealing with it. So, the thing is, our users already have like Google Cloud credentials on their machines, so we wanted to just use that because we could just use a GCS bucket. So we kind of figured that out. We already had an Nginx machine on users, or sorry, an Nginx process on users' machines, and we just kind of like did some crazy shit with Lua to inject the auth. So like, yeah. So that sort of works. All the code that I reference here is posted there. It's like linked again at the end. But yeah, so we wrote like a gcloud.lua that just rips the credentials out of the user's home directory, injects them into the request, and like forwards it on and pretends it came from something that wasn't GCS. But that doesn't answer like how do we fill the cache, right? You wanna actually upload build results. So we it turns out there's this thing that just pretends to be S3 and actually uploads to GCS, and NixCopy is capable of uploading to S3. So we have this post build hook that we configure. I think there was a talk about this, I missed it, but yeah, post build hooks are cool. We essentially just, when we finish a build, we mark it in like a spool directory, and then we have a background daemon that comes and picks that up and uploads it. But uploading it means basically we run NixCopy to this endpoint thing, which is in our Nginx, which then decides whether it wants to like pretend it uploaded it because it suspects it already exists on cache.nixos.org, or upload it to a local instance of Minio running on the developer's machine, which then injects the credentials to upload it to GCS. So that was fun. Is there a better way to do this? Probably. I couldn't figure it out at the time. So the other authentication thing that I've had a lot of trouble with is like authenticated gems. So this is probably a problem regardless of the language runtime, but like we have gems that are private. They're specified via like a pre-shared token to a private repository via the user's like some personal access token they have stored in macOS keychain for GitHub HTTPS, or maybe via like GitHub SSH. So that's 3 different mechanisms that are all kind of not like really easy to get working. And then you take like the cross product of that with having to support getting that working in like actual Nix land, and then also in prefetch land, because if you're using like Bundix or probably any of the like equivalents for other language runtimes, you have a whole different phase that has different code, and like it's not the same. And then you kind of take the cross product of that with like, there's different types of credentials on different types of machines, right? If we're using like Google Cloud, we'll have one kind of like actual real user credential on a developer machine, but then a service account on a CI machine. So like, I don't know, man. It's, we're getting there, but this is like way more painful than I thought it was gonna be. User interface is another thing. So this is something where I learned things today, but so I'll explain what I learned in a minute, but this is running dev up in a thing that's using Nix, and it's quite pretty, I think. It's got a spinner, and it's spinning, and it's downloading stuff. Right now it's downloading Ruby on a not super fast connection. There we go, gems, great, and we're good. So, there, cool. For that, I ran like nix-build or something with -vvvq, and that generates a lot of output. And I wrote a really fun state machine for that. I discovered today that Nix space build has much better output than Nix-build. So that's going to look different next week. Yeah. The overall workflow is something where I think we've actually figured out some cool stuff, and it might actually be similar to Lori, which I haven't heard of until today either, because I live under a rock or something. So the two main ways that you can that are the two main obvious ways that you could interact with a set of Nix packages for a project type deal. You have you could put them into a Nix profile and use NixEnv to manage it, or you could use Nix shell. I wanted to kind of maintain the same workflow we've always had with dev, which is the user CDs into a directory. And I guess I didn't explain this, but part of the motivation of dev being a shell hook is that we activate a lot of environment for people when they change into a project directory. This has been really case by case specific and hard coded for a long time, but with Nix we necessarily have to make it a little more generic because we don't know ahead of time all of the things the user might specify as a Nix dependency. So backtracking to the current slide, Nix shell is not happy for us because we don't want to make our users run a subshell. We want them to just change into the directory. So on that metric, NixEnv is the apparently correct solution. Or we could do some crazy hacks with Nix shell to export that environment and do other things with it. And I went down that road and it worked okay. But the problem with that road was that so NixEnv sets path and man path. When you activate a Nix profile, you get path and man path, which if you only care about binaries, that's great. But when you run Nix shell, a cool thing happens, which is that you get a load of extra environment. And sometimes you want that environment, like gem path, for example, is set. I'm talking a lot about Ruby. It's because I write a lot of Ruby, and I'm sorry, it's a horrible language. You can deal with this for now. It's not horrible. It's slightly horrible. Anyway, so you get some of these extra variables in Nix shell. The problem is when you run Nix shell, you also get CC and LD, and that means you get the patched or wrapped version of the compiler and linker that completely reject to do anything outside of the Nix store. And because we're in this situation where our projects don't actually have build phases, we're kind of straddling this boundary where maybe people want to build something that's not in the Nix store because we're half in this world. We don't want all those variables. Really, NixEnv does not give you any of that environment. I'm sorry for anyone that's colorblind. I should have thought harder about this. These are all red. These are all green. Nix shell activates all of that environment, but we don't want all of it. What we actually want is just the top level, which is the first order dependencies of the actual profile that we build. And maybe this exists and I just don't know about it, but I couldn't find anything that kind of does this automatically. So we built this tool called ShadowEnv, partially motivated by this. It takes this, here's an example of, so it's Lisp because I wanted to assign some environment variables, and I wanted conditionals, and this is the simplest thing I could figure out. So it takes that and turns it into this behavior. This is basically the same thing as Duranv, but I didn't know about Duranv when I started building it. And then I kept it because it only gives you access to the existing process environment when it starts, and nothing else. And it's actually a pretty smart bytecode interpreter and stuff too. So it typically completes in tens of milliseconds, if that, and it's hard capped at 100 milliseconds. So when I would play with Duranv, it doesn't seem quite reasonable to run it as a shell hook all the time, or every time you open a file in an editor, you have to care about asynchronicity and things like this, where ShadowEnv is it's essentially instantaneous. So I run it on every shell hook and opening files in an editor. So ShadowLisp is a compilation target. But then so ShadowLisp is decidedly not bash. So how do we generate that for our dependencies? Well, so if this is the expression that our project uses, you can see there's MySQL, Node.js, some gem thing, Ruby, shell check, Z shell. We take the references of that profile, which is okay, it's a list of Nix store paths. The way shell those environment settings actually work when you load a Nix shell is you have these files. There's a special file within a Nix derivation output path, or whatever that would be called. Nix support / setup hook that contains a fragment of, I guess, bash, some sort of shell thing. And this is meant to be run with standard end / generic / setup.sh loaded. That defines a bunch of functions that kind of exist in the default builder, and so this is all run. These are literally just sourced into a Nix shell as you load them, but there's not that many functions, so we just kind of made a translator it's actually a bash script that just implements those functions, but prints those things to standard out, and it works pretty well. So then on dev-up, we like install all the Nix stuff, tag it as a GC root, compile the shadow env, and then write it out so that it gets loaded automatically. So then this is actually the same as before, but I'm going to draw your attention to the part at the end after it finishes downloading Ruby. Yep, that's a spinner. Okay, so as soon as this is done, it says generate shadow env and then activated shadow env. So then it's active. And if you like change directory out and back in, it works. If you open VS Code or something and have the plugin installed, it is just sort of transparently the right environment. So very similar to durenv, but faster. So this is kind of like in the real world example of what that looks like. The top chunk is just kind of our activation of our sort of fake profile. We set dev profile to the path. There's some weird crap about Ruby because Ruby is a weird language to activate because it depends on, I don't know, a dozen variables. Stuff translated from the setup hooks, and then more specific Ruby stuff because cool. So yeah, the next things I'm going to work on are like actually getting gems authenticating properly. But then the thing after that is like dev does a few things. Dependencies are the major one, but it also like allows you to specify those test console server build whatever commands. What I really want to do is like have it in a situation where you can say something like, this is a Ruby project, and have that generate like a Nix configuration fragment, but also generate some widgets for understanding like kind of what sort of test setup are you going to use, and like what does it mean to run that, and maybe you have like a Ruby and a Node.js component, and it kind of intelligently gets how to run tests for both or make you select. And so I'm trying to figure out how much of that to put in like Nix land and how much of that to do as a sort of YAML-like wrapper around it. I don't know. That's what I'm doing. So, yeah, like, all this to say, when I started this project, I knew just enough Nix to know that it was probably the right thing to do, and now I barely know any more, but, so if anybody knows a lot and wants to come help me, that's cool. But questions?
So you use the tool dev-up and dev-test. Why don't you use make with makefile?
So that is actually, I was using make like very early on. The reason is like, make is definitely a reasonable way to specify like server console build test, those things. But for dev up, it does a substantially more complex thing. Like, it's probably possible to do that with make, but it would end up, I think, with more configuration in the individual projects than I would have wanted, and you'd have a lot of like transient, like Sentinel files that it'd be possible, but this felt cleaner.
One more question. So, how often do you update your packages and Ruby itself? Because it seems that you have a lot of things hard-coded, like Ruby version and all that.
Yeah, I want to get away from that. Right now we have the like x.y.z Ruby version hard-coded, and I think that's a really bad thing that we should stop doing. So I like that Nix conveniently does what I think we should be doing, which is just depending on the minor version. How often do we update it? So it depends on the project, right? Because we have that hard-coded, like our really core projects will run the most recent release, but then other projects can languish for years without getting an update, which is bad, and switching to Nix would help that a bit.
So I didn't quite catch why are those environment variables you get from Nix shell a problem for you? The CC and so on, all of these transitive dependencies that said.
Yeah.
What issues did you have?
So I'm trying to remember specifically. So first off, there's just a load of them, right? Like you get all sorts of kind of like Nix internal looking things, a whole bunch of things from the derivation that just aren't like they're environment variables in the builder just because that's how the builder works, but it doesn't really make sense to export them to a user's shell if you really think about it. Because, sorry, from the perspective of I'm aborting that sentence. The real thing is like, because we don't have build steps in most of our projects, you'll get the occasional case where somebody decides that this project does have a build phase and we don't manage that in Nix land, right? So then when you try to compile something in your local project directory, that's not in the Nix store. And then like CC and LD are not useful values for us because they break that. On top of that, looking through it, I didn't find a single value where I got a transitive dependency that looked like it was an environment variable that I actually wanted. I don't have anything super concrete for you. It just was a subjective, it feels better if I do it this way.
All right, cool. Thanks.
I would just like to, continue with this thing. I think you could get rid of parts of these even in Nix shell. For example, there is a modified stdnf that does not have a C compiler.
Yes.
And but I'm afraid some things would probably be still left, like things around the stdnf, some hooks and such things. So it would possibly not work for you.
Yeah, I realized that as I was talking just a minute ago, that I could totally reasonably. But then you'd have packages in your actual build that would depend on CC, right? So even if you may, we did at any rate, even using standard env no CC, there was like something that depended on CC. I don't know.
I really like the shadow env stuff because that's exactly what we are doing for Lori, basically. And
cool.
I think we're gonna steal that.
Please do.
So we have the same problem, like which environment variables do we actually need for the user to see, and how do we have a nice interface for them to specify what they want and what they don't want.
Yeah.
Maybe we should talk about that.
Yeah, there's probably things I should steal from you too, so I'm happy to chat about this much more later.
Did you consider installing NixOS on all those MacBooks?
You have no idea how much I'd love to do that. No, actually, like our VP of engineering and I think even our CEO are like pretty positive on the idea of like, hey, what if we would just move all our developers to Linux? Nix feels like a good stepping stone to that because of it working just fine on both Darwin and Linux. I figure if we can get everybody transplanted onto Nix, it becomes a fairly small thing to just move the platform. I know, like, that's not going to be an actually small thing, but eh.
So another question about the usage of that at your company. I don't know if I missed it, but can you tell us like how many people use these environments now, and how the support is, or how you do support for them when stuff doesn't work? Do they investigate like into the Nix depths themselves? Do they go to you? How do you organize it?
Yeah, sure. So right now it's actually just a very few people, but within 2 weeks we're going to roll it out to our major application. So I don't know, but I don't anticipate, like, I kind of expect, okay. Actually, Nix is running on about 2,000 laptops, installing Minio, and that's about it. So we've kind of dealt with the initial round of triage for that, and we found it basically works everywhere or nowhere. So it doesn't tend to be that people have to do a lot of debugging unless they have a different configuration from everyone else, which like is obvious given what Nix is, right? So that's great, and I love that, because the most annoying part of my job is dealing with the person who like 8 years ago installed ngrok and now their hypervisor doesn't work. So yeah. All this to say, I don't anticipate subjecting a lot of users to their own debugging, because it should be broken for everyone if it's broken for them.
Test.
Hey.
Okay, great. So you have this nice environment for managing versioned Ruby interpreters and gems and dependencies in developers' environments on MacBooks. But then when they deploy to production, it's on Linux. Are you also deploying with Nix package in production, or do they just run against the Ruby that happens to be installed with the system package manager?
Yeah, so not yet, but that's part of my secret plan. Once we get all of our development environments specified using Nix, it becomes really appealing to replace our existing container builder with, hey, let's just export this segment of the Nix store. Definitely planning to do that sometime next year. That looks like it. Thank you.
So that's it for today, and all there's left is to have some fun. I'm told beer is ready for us, so have fun, guys.